Hello, hello. Herzl, who is too slow? Others? Microphone. Hold on. No, it's not wrong. I just didn't move it. I. All right. I'm going to work on cast again today. And the penguin operator. Hi. Alright, I'm going to continue where I stopped yesterday. I did not fix the bug, so I'm going to try and fix it today. We'll see if that is the thing. And then we are going to be missing name types, place expressions, compared to the previous implementation. And also, I remember there is another thing that is missing, which is macro hygiene. It is currently not implemented. That's another thing. I think after these three, we are better than the last version in all aspects, right? And then there is also advent of code, which is probably going to happen before I implement some of these, probably before macro hygiene. I'm not sure about like which one of these is more important. Place expressions maybe is actually more important than the names type, so I would like maybe like something like this is the plan, right? And these guys can happen during the advent of code maybe. Yeah, so if I fix, then I go and do the place expressions today, and if I don't fix, then well, then it's going to be, I don't know then. All right, let's do this and open the VS Code. Do you accept contributions to improve the standard library? Sure, I guess. I don't know. I mean, it depends on what is the contribution. Because right now everything is moving all the time anyway, right? Like, what do you want to contribute? I was actually thinking that maybe the standard library should go into its own repository. I would use it like as something, you know, either a Git submodule or just a Flake input. All these methods can be implemented with fold, so if you add a native fold, we can add all the other useful lists methods. But you can implement fold using the current thing. We already, like, you can already do the fold. I'm just missing the substitution to be fixed so that we can actually work on the standard library, right? Because right now you can iterate, and by doing the iteration, you can implement the folding, right? Wait, what? Hold on a second. My lists, yeah, my lists right now are written entirely in the language, so you don't even need to do the fold. You can write the fold yourself. He's halfway there, looking like the senior dev. What's the senior dev? And what do you mean halfway there? Quest of Joy. Hi. Not in pure. What can you not do in pure? Doing the iteration, you can do it in Haskell. In Haskell, the mutation still exists. There is, just like in OCaml, they call them references. Messy hair, facial hair, head hair, yeah. All right. Yeah. Um. Yeah, there are references that you can mutate in Haskell. They're called. You can work in the st monad. You can work in state monad and stuff, right? You can implement that all inside the language itself. It doesn't matter if the language is pure or not. Like right now, the lists are implemented in the language itself. So like, you can do whatever you want. Right? You can implement the fold yourself. Currently, if I fix the bug, of course. Yeah, but like later I plan, like, because this is bad for performance. This is not the list that I want in the language for performance reasons. So because of that, we will want to have arrays actually as a native thing. And then we will probably implement lists using arrays, similar to vectors in C++ or Rust, right? I just don't like calling them vectors, but we'll probably want something like that instead. Okay. But we'll see. It's not necessary for the advent of code. The only problem is like getting the value at a given index is taking linear time with this data structure. And you do want sometimes to get an element at a given index, right? Sometimes you, yeah, sometimes you want that, I guess. But there are other alternatives to like this. All right, anyway, we are going to fix the bug. So what's the bug again? Let's go over it one more time. What is substitution? So yeah, over here we have a function create a list. This accepts a generic variable called create t, so that it's different from the other t's, but basically it's a t here, right? I will change it once we have the bug fixed. So it's a function that takes nothing and returns the list of create t's, right? But when we actually instantiate this generic with create db in some concrete type, right? So for example, a list of integers, we need to change this from being list of creatives to being a list of integers. So that's called substitution. We substitute the variables with their values. That's it. And that thing is buggy currently. So let's get fixing this. Like because of all of the things that I've introduced, it became buggy. Let's run the LSP support and cast run examples list, right? So right now we have this. Right now I actually have the infinite recursion. I was trying to fix it yesterday and I didn't succeed. So let's see if I can succeed today. So what's happening here is because we have sometimes we want to substitute the value that we don't even know the value of yet. So we want to substitute something that is not inferred yet. So what do? Because it means that the substitution can only happen after the thing has been inferred, right? So yeah. So how do we do that? Right, and then, so in order to do that, we basically finish the substitution only once the variable is inferred. And before that, we say that the result of substitution is new thing that is not inferred for now. Right, and then what's happening, I guess, is that I am... And then what's happening, I think, is that I am... trying to substitute this variable, this new variable, once again, and then this new variable creates a new variable, and then I substitute that, and then we go in the infinite loop. So maybe we can just fix it in one line of code, which means that I am going to add to the substituted variable to not only the ID of the original variable, but also the ID of the new variable, so they both are supposed to be the same thing, right? So let's do that, yes. How about that? So we do inference for recurse ID of the substitute temporary variable into get for like this. Let's see if this is going to fix it. It didn't fix it, which means that we are stuck, and I don't know what to do now. Alright, here we go. The 5 hours of suffering are going to begin right now. And, can I fix it or not? So we have an infinite loop. Specifically, if I try over here, say that I'm substituting this variable, right? I'm pretty sure this is still the case. Yeah, I'm substituting the new... So I'm creating the new variables while substituting the variables. That's what's happening. Oh, we are ready. We're ready for what? For another replicate run? I cannot fix the bug. Should I play replicate then? I don't know. The language is ready. Almost ready for the advent of code. Not ready for the game jams yet, though. Yeah, no. How's your game going? Are you a billionaire yet? 100 reviews. Is that good for the 3 days after the release? It's been 2 weeks, right? Nice. I discovered your YouTube channel and saw that you started a version of casting Haskell. What made you change and not use Haskell anymore? Haskell was very annoying. Specifically, the most annoying feature of Haskell is the records. I really hate the records so much that I dropped the language. Was there other reasons? Yes. Other reasons are the language server for Haskell absolutely sucks. So the only way to actually work with the language is to run the compiler all the time. And the only way to rename a variable is to do a grep, I guess, like find and replace textually. Instead of using the language server, go into definition, doesn't work. Like all of these things, they don't really work. So yeah, Haskell is a nice language in theory, but in practice it's really horrible, in my opinion. Yeah. The Monad stuff is nice. I was using the effect library in Haskell. That was nice. It's almost... yeah. You know, the records are really bad. Are you a fan of Haskell? Also, Haskell has a slow compilation time, by the way, similarly to Rust, right? So, the big project... I mean, I have not tried making a big project, but I heard that Haskell is really bad with compile times. So yeah, and the reason why I switched back from Rust to OCaml is the compilation times. So yeah, out of the three, technically, I think like OCaml, Rust, and Haskell, I think Rust is the best practically. But for this project, just because for this project, I cannot structure the code properly so that Rust can compile quick enough because of the highly recursive nature of my language. That's why for this project, OCaml maybe is better, but I'm not sure that it's actually better. Because there are a lot of things that I give up when I go from Rust to OCaml. Can you see my language syntax? Yeah, hello, Sushi Thrash. My syntax of my language, so the thing about the syntax of the language is that it is extensible, but there is the default syntax, obviously. And currently, it looks like this. Here's the hello world. Let me show you the working version of the language. If I can. How do I show you? Like okay, I guess in the playground maybe. In the playground maybe. Is it working on the playground? Oh, look at it's working. Yeah. But I mean, this is the smallest example, right? This is just printing hello world. Yeah. It's just right now my syntax highlighting is broken because my language is broken. So I mean, but other than that, you can see here's a guess a number game. Let me maybe copy this into the playground. Yeah, there we go. So this is a program that is a guessing number game, right? We choose the random number and we try to guess it. So we say 5 and it says that the number is greater, and then we guess it and it stops. So that's how this program looks like. Kind of like a normal programming language, I guess. Sushi Trash. Yeah. Are you using sort of IR or are you just interpreting it on the go? Right now I have the interpreter, but the plan is to have the compiler too. But I'm going to target the not native things first. But instead I will go the transpiling route to there was there is a starting thing where I was transpiling to OCaml, and then there is also in the previous version there was a proof of concept transpiler to JavaScript, and maybe I will actually go the JavaScript route again. I don't know, like we'll see about that. Maybe I will continue with OCaml. But JavaScript is like the obvious way to go. Right now I don't care about the performance, so it's just JavaScript is the easiest one to generate. Hello, Elemental Magic card game. All right, let's see how to fix things. Substituting the variable. So why am I generating a bunch of variables? I've never really used Haskell for any project, but it seems cool. I heard the Terling is terrible. Yeah, like the Haskell is the language that is good on paper. And well, I mean, technically, like you can get used to the tooling being bad, right? You can get used to writing code without a language server and just relying on the like compiler, running it in the background all the time or whatever. It's kind of okay, but like it's just like the refactoring is difficult. If you never refactor, then just writing the code, I guess, would be relatively fine. Elemental Magics is the Haskell person here, right? Yeah, how's your game going? Haskell libraries are good, tooling varies. Yeah. Alright. Some Haskell tools are S tier. What's the Haskell tool that is S tier, for example? I mean, the compiler itself? You don't know an interpreter better than GHCI? Yeah, I guess GHCI is probably a good thing. Although at the same time, I'm not really like sure, like, why would you use a GHCI? That was my question. Like, okay, so since you use Haskell, what do you use GHCI for? Because I don't really understand it. Like, why would I go in, like, why would I go into the interpreter if I can just write, like, does it help me write the code? I mean, maybe you need GHCI because the LSP sucks. That actually makes sense, you know? In order to explore what you can do with a type, you do it in the GHCI because the LSP cannot tell you a thing. That's probably that makes sense now. Okay. Yes, you can type I and T for things. That's the thing that is the LSP supposed to do. Okay, it makes sense. So because one tool sucks, they created the other tool, which is a little bit more manual, and yeah. Okay. How did you go on with making a standard library? I'm also working on a language of my own, but I have a very shitty approach for making a standard library. I don't know, what do you mean by the approach of making a standard library? What are the possible approaches? Probably more like GHCI is so good, they didn't need to make a good LSP, but it's not true for other languages. I don't know, I feel like if you had a good LSP, you would not need GHCI. Do you have native functions exposed? Okay, let me show you. So here's my native function print, for example, right? We have here's my standard library, std io. This is the function print. This is the function input, right? Right now, I just have the instruction in the language, which is called the native instruction. So this is just basically a string, and then in this case, the interpreter knows how to perform this thing, right? So a native print is just evaluating to a value that is known to the interpreter. In case of a transpiler, this is going to be known by the transpiler how to like do this thing, you know? So yeah, something like this is what I'm doing. One thing that's good about REPL is quickly checking the values and calculations. Lin has a feature inside of the LSP. Is Lin LSP good? Yeah. Yeah, quickly checking the values and calculations. I think like it's like the LSPs for Python like allow you to do the same. You just like select the code and like right click and like run it or whatever. OCaml REPL is also quite good for REPL-driven development. So for the same reason, because the LSP sucks. LSP in OCaml is better than in Haskell, but it still is kind of bad, I guess. I don't know. What's your language? Sushi trash. Any links? But yeah, hopefully that answered your question. We just have the native instruction. This is a dedicated instruction that the basically the compilation target knows about. And we have like we will have the interpreter as one of the compilation targets, and then there are going to be others, right? like JavaScript. If I am going to transpile JavaScript to OCaml, maybe I will eventually transpile to C, or maybe we'll go to LLVM and like some other paths, who knows. Yeah. But I need the interpreter because I have compile time evaluation anyway. So we start with that. Hello, Veldek. Use protection, avoid STD. Yes. All right, I'm substituting a variable, and this goes on recursively. Beautiful. Why? 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 Oh, it's because these things, they create the new variables all the time. That's the reason. That's why I was counting the substitutions before, to know if over here, if something actually was substituted or not. But now, because like we cannot even know if something it was substituted or not. Huh? Oh, but I need to like unite it with the original variable. Okay, if actually something was substituted here. Yeah, we like lose the original variable always. Okay. I see the problem. So how would I fix that? Because I can no longer just count the substitutions. Because we don't know. Let's maybe like so that you understand, so someone else understands what's happening here. We can try to simplify the language. Like, let's go into OCaml Playground and make the minimal example of what is actually happening here, right? So let's say that we are doing type inference, right? So when I'm doing type inference, we basically have something like this. We have type, right, which is either like, let's say, an integer, right, or a list, or a list of other types, right? And then obviously, since this is inference, the type is potentially not inferred, right? And then not inferred, this over here, it's we have like the variable which stores the data, like, of the not inferred thing, right? And variable is something where, you know, like we have some data, and then we have like, let's just say that's inferred. Let's just say that like this is some type, right? I don't want to expose too many details here for the sake of the example. Let's just say that the variable has ID, right? That's it, ID. Right, and then ID, whatever, an integer, right? Let's do this. Variables have IDs. So once they are inferred, we will have basically this ID corresponding to some specific thing, right? And then we have API like this. We have function like once inferred, right? This is a function that takes variable and takes a function taking a type, right? And this is just going to call this function once this variable is inferred, right? Function variable f, and then like I don't know, some implementation, right? There we go. So we don't expose the thing, right? And then we also have, oh yeah, and then we have the one other very important thing, because the types can be like the types calculated inside of the generics, right? Or generic types, generic functions, right? So we want to have like it's not a variable then, right? I mean, this is like the inference variable, and this is going to, so I call them bindings. I mean, yeah, sure, let's just call them bindings, right? Binding of binding, you know, where binding is just, let's say name is string, right? So for example, the type can be just t, right? When we have code like function f is generic function t, which takes which is a like the id function, right? What's the id function? It's generic function taking x of type t and returning x back, right? That's the id function. So the type here is t, right? But when we actually instantiate, like basically what is the question is, what is the type of id for integer, right? The type of id for integer is going to be integer into integer, right? Instead of it being t into t. But the type over here is just t into t, right? So that's the process that I'm trying to do here. It's called substituting the bindings. So basically, I'm trying we need to substitute. We got like t into t, and we're substituting with t equals int32, right? When we are instantiating this generic, so we get int32 into int32 as a result, right? That's the goal here, right? So for that reason, we have the function that's called substitute. Let's just call it sub, right? So we have the function substitute. This is a function that takes in type and returns the type, and it also has the you know, let's just say that I think sub is okay. So it also has the string map from string into type, which is like the actually substitutions, right? Yeah, let's just say module string map is map make string, right? Something like that. So so what we want basically is, if we try to substitute string map like singleton, we have like variable t equal to int32, right? And we substitute the function. Okay, let's say not list. Let's actually have like function, and function has you know, argument which is type and result which is type, right? Yes, just to follow this example of id. So we are trying to substitute the function type, where argument is binding, name is t, and result is binding, name is t, right? So let's say okay, Yeah. So this is subbed ID is going to be equal to that, right? And then I just want to like assert that subbed ID is equal to a function where argument is int32 and result is int32. So you would think this is really easy, but it's actually not. P. Gorley, hello. Bindings, type into in parentheses here. Yeah. So that's what we want. So right now, do an exec this. So this obviously doesn't do because right now I'm just not doing any substitution. So the trivial implementation is we just do match on type, right? If we have an integer, then we get back an integer. There's nothing to substitute here, right? If we have a function with argument and result types, then we get back the function where argument is substitute. Argument and result is substitute the result. This is a recursive function, right? And then if we have actually a binding name, then we are going to do a string map. We are going to find, is this a binding that we can replace with an actual value, right? So I'm going to find name in the bindings, and if it exists, some substitution, then we return the substitution, right? And if it's none, then we just return the original type, right? Or let's say just binding name. We just return that back. And then the last thing, which is the variable. The inference variable. So what do we do here? And that is the question. This is not inferred. This is a variable, basically, right? So variable is potentially actually inferred. It's just... yeah. So yeah, this is the minimal example. So how do we do the variables? That's the question, right? Because we don't know, they are potentially not inferred yet, and we can only do something once it is inferred, right? So for that reason, if we see a variable, what I'm doing right now is I am creating a new variable, right? So the result is going to be a new variable, right? ID is a new ID, whatever. Something. That gets colored because of uninferred. Because of once inferred. Colored. Well, not exactly. Because it is not async anymore. It would be colored, you mean like it would become async function if I was calling another async function, but it's not exactly that. It would be colored if I was calling the await inferred. But once inferred is just registering a callback, right? So yeah, because we don't know the actual value of this variable yet, we don't know how to substitute, right? Because of that, the only thing that I think makes sense is to create a new variable and return that, right? But we actually need to assign something to this variable once this variable is known, right? So we do something like this. We say once the variable is inferred, we're going to do something. And the variable is inferred to be as a variable type, right? So what do we do here? What do we do here? If this is the type, then what we want to do, we want to substitute this variable type, right? Tab also takes a type into unit callback. No, it doesn't. No. It doesn't because I guess like that's not all of the API that we have. We also can say that you know, we have the function to unite variables. So this takes one variable and another variable and makes them the same, right? So these two variables are equal basically, right? Function A and B. Yeah. Yeah, I mean, yeah. And we can also assign it to like an actual value, which is not a variable, I suppose. Assign, let's just say that we have assign, which is like assign a variable to an actual type. Right? So what we're doing here, I'm substituting the value of the variable once we know it, right? Using the same substitution bindings, right? And then I'm going to and then what I'm going to do is basically I'm going to say that result is equal to this, right? So I'm going to say I'm going to assign result to the substituted variable, right? Something like this. Does that make sense? I guess it's not like we can just say that we can unite. Let's just say that we can unite two types. It's the same, right? So I'm just trying to unite the result is equal to this thing. There we go. What happens if you delay all variables to finish getting inferred before substituting? I cannot always wait for it. Wasn't this like the first thing that I was trying to do? That was the first thing that I tried to do. Let's see what happens. Sure, let's see. So we basically say that we don't do once inferred, but we await inferred instead. One thing weird in a camel is that the type parameter goes before instead of after. Yeah, doesn't really matter though. That's just a syntax thing. I think it's whatever. It is weird, yes, but whatever. It's like a tiny thing. Yeah, that's what I was doing before, right? Not exact. I was doing inferred opt. Yeah. Hold on. Why was this not working? You can see how it could cause a deadlock. Yeah, I think there was a deadlock because of that. Yeah. Literally the deadlock. Let's see the definition of the recursive type, right? We have a list. We have a list over here, right? This is the generic function, right? So we need to figure out we need to substitute the bindings of the list t, right? So to, like, let's say that I'm trying to create a list of integers, right? And ignore all of this code after. So this is all the code that we care about. Let's copy this separately into the playground, for example, right? So how do we know what's the result of list integer? Right? So we need to evaluate this and then substitute the bindings, right? So what's going to happen is that this thing over here, since this is a recursive thing, right? How can we know what this is before we calculate what this is, right? And in order to calculate what this is, we need to substitute the bindings, and that's how we get a deadlock. Yes, exactly. It's the deadlock is happening because of the recursive types. Wait, actually, how am I? Yeah, how is this even supposed to work at all? How is this supposed to work at all? Let's just make the type even simpler. Let's say that the type is literally like an infinite list. Why not? Because we have the first element, right, head, which is t, and tail is list of t, without even any options here. So a type, just a structure like this. Literally an infinite list. So yeah, so in order to in order to know what's a list in 32, I need to evaluate this type, right? So I'm evaluating this type. Hold on. No, this is a type expression, actually. So I can evaluate this. The head is going to be equal to int32. That is easy to evaluate. And then tail is going to be equal to list t. Oh, yeah. But wait, what? No, hold on. Wait, what's the problem? So this one is going to call it recursively. And for that reason, we already say that when I'm instantiating the generics, I'm initializing them to the not inferred variables and then calculating the background. So this is going to be equal to something that is not inferred. And I'm going to go ahead and evaluate what is this. T is int32. And then we evaluate this. And this is the same not inferred variable. So we return that and we assign them. And that is supposed to work. But what's not working, I guess, maybe is me compiling this. No? Hold on. Does this even work? Yeah, right now this is completely not inferred. How is this supposed to work even? Hold on. Yeah. So this cannot infer this thing. This is the old version. Oh my god. Let's Streamer doesn't know how his thing works. Yeah. um like this is supposed to Oh, no. That it makes sense, right? It makes sense. Yeah, exactly like I was saying, right? So what's happening is we are trying to evaluate the expression list int 32, right? So which means that what's the first thing that's happening is I'm basically saying that list int 32 is like, let's say, a new variable, right? Which we don't know the result of. So we are doing this assignment, right? And then we are trying to calculate the body of this in the background, right? So in order, we are trying to evaluating this thing, right? Head is t and tail is list t, right? But we know now that the t is in 32, right? So the head is t is easy to evaluate. The tail of a list t, because it's a generic, we are going to basically so we're going to replace this with an int 32, and we're going to replace this with the variable, because that's what we have assigned this to temporarily, right? And now, in order to know the final value of the list of int 32, what we need to do is we need to substitute the bindings here. And I cannot do that because this is not inferred yet, but this will only be inferred after I have finished the substitution. So we have a deadlock. Yes, okay, that makes sense. But technically there is kind of nothing that we should be substituting here, I guess. So the question is, do I even need to substitute the things? Why do I need to substitute the things? Why do I need to substitute the things? I know why do I need to substitute things, because substitution is supposed to happen for the when we have a generic function. So maybe generic type and generic function are a little bit different. So like, for example, when I have a function f, which takes which is generic function, right? I mean, literally id, right? id is a function that takes x of type t and returns x, right? Generic function, the easy one, right? So when we want to try to see what is id int 32, right, we first say that id int 32 is equal to variable, right? And then we try to evaluate what is this function. So we know that because I want to compile this function only once, because of that, we basically use the original function, which is x is t into x. And this is where we want to substitute the binding, because we want to replace t with an int 32. Okay, yeah, that makes sense. Kind of, I guess. Maybe I'm doing things a little bit wrong. Because, like, I only need to substitute the bindings on the type ascriptions. No. It's not only the types that would be, like, substituted. No. Or yes. Or no. Or yes. How do the other languages do the generic types? I have no idea. Maybe we should research this thing a little bit. Should I look into the Hindley-Milner stuff again? Type inference tutorial. Let's see how. Is there a tutorial somewhere? Type inference with generic types tutorial. Somewhere. Type inference for beginners. Like, I don't want subtyping, but it is about higher kind of types, I suppose, maybe. I mean, not really. Or is this already a higher kind of type, supposedly? Just for the lambda calculus. Part 1. Where is the other part? Where's the other part? I just asked ChatGPT. So how does inference algorithm work when there's generics involved in a Hindley-Milner style? I don't know. Let's see what it says. Let polymorphism, the Gaussian grows extra has. When you enter the let binding, you infer the type of the right side normally. Just usifying constraints like always, then you generalize. I mean, yeah, I don't want the let polymorphism. Instantiated usage. That's what yeah, what does that mean? The inference algorithm of generics. Plus these two rituals. How to instantiate that usage. Take the polymorphic type scheme like this for all A into B into A, and you clone into a fresh monotype every type the variable is used. To look at the type scheme, it's something like this for all this. Then take a mapping for each quantified variable. Take a mapping from each quantified variable to a fresh type variable B. Fresh means brand new. No history, no baggage, like you wish your code base was. Substitute all occurrences of AI inside T with these fresh variables. Okay, there you go. It even says it here. Substitute. But in order to substitute, like that's literally what I'm doing, right? But in order to substitute, but in order to substitute, I need all variables to be inferred, right? No, you don't need everything inferred first. Instantiation happens before inference finishes. Yes, that's how we want it. When you instantiate a type scheme, you are not substituting with fully known types. You substitute the quantified variables with fresh unknowns, pure unresolved type inference. That null will become known later when unification slams. Example. But this means that when I substitute Hindley-Milner does not have recursive types or type bindings, so they have none of the same problems you're having. Okay, so it's because my language is better. All right, got it. So wait, Hindley-Milner does not have recursive types, really? Does HM have recursive types? They don't? No. Okay. Yeah. But there are some Hindley-Milner extensions that add equirecursive types. Unification tries to solve infinite trees. I thought you were lurking. Oh, you unlurked already. All right. But the algorithm mutates into a beast that growls every time you run it. Okay, so that's what's happening, right? Okay. Wait, so like what we so what is the algorithm that is like used in Haskell? It's not Hindley-Milner, right? Hindley-Milner is not like the basic algorithm without the recursive types. But every language has recursive types, right? Every language that is usable needs to have recursive types, right? That's ADTs. So how to do a substitution in presence of recursive types. The two big camps: isorecursive types. You wrap, unwrap explicitly. Substitution is boring, totally fine, no drama. Equirecursive types. A type is literally equal to its unfolding. Substitution wakes up a hydra. So like that's what I'm doing, right? A type is literally equal to its unfolding. Every step is building an infinite type unless you control it. I'm assuming you mean equirecursive, because that's the one that causes suffering and makes your question actually interesting. Right, isorecursive type. Substitution is trivial. What is isorecursion even? If your type is this, then substitution is to just extend the binder. I don't understand this. Isorecursive types. Recursive data type. ISO. Revisiting isorecursive subtyping. Okay, beautiful. Full isorecursive types. There are two well-known formulations of recursive types: isorecursive and equirecursive. Okay, let's see what this is. Let's do a little bit of paper, a little bit of theory. Fine. Oh no. Recursive types are used in many programming languages to express recursive data structures or recursive interfaces. There are two well-known formulations of recursive types: the isorecursive and equirecursive types. And the equirecursive types are recursive type UAA and its unfolding UAA are equal, since they represent the same infinite tree. With isorecursive types, a recursive type is only isomorphic to its unfolding. To witness the isomorphism, explicit fold and unfold operators are used. You guys understand that, right? Right? Because both formulations provide alternative ways to model recursive types. The relationship between iso and equirecursive types have been a topic of study. Understanding this relationship is unimportant to understand to answer questions such as whether the expressive power is the same or not. You know what isomorphism is? Yeah, I guess. Theoretically, the full isorecursive types offer the expressive power of equirecursive types, but with a more manageable meta theory. This allows for future extensions with more advanced type system features. Complex type system features such as type level lambdas found in system FW can lead to undecidable type equivalence relations with equirecursive types. Isorecursive types provide explicit control over unfolding and unfolding, avoiding issues with undecidability. You know what relationship means? The lambda FIU calculus, the Coq formalization. This section provides an overview. All right, let's see the overview. Equirecursive types treat recursive types and their unfoldings as equals. What is unfolding? Unfolding is when you replace the variable with its value, right? Yeah, okay. That makes sense. I think that's what I'm doing, right? So I'm doing the equirecursive types because I want these things to be equal, right? The advantage is that they are simple to use, since there is no need to insert explicit annotations in the term language to transform between equal types, as shown as in rule type ec. Alright, what does this even mean? So we have this, that, and this. We have some symbols shown on the screen. E is A dot equals B. E is B. You know what is that equal sign? So I guess this, okay, so I can kind of like understand what's happening here. So I think this is the typing context. This means that in the current typing context, the type of variable E is A. And we know that A is equal to B. Then it means that the type of E is also B. Is that, wait, what? Like above we have like the input, and in the bottom we have the output, right? Like the result of inference. Equals, but with a point. Yeah, they have a point. The meta theory of equirecursive types has been studied. They propose a tree model for specifying equality or subtyping. In essence, yeah, I don't care about subtyping for now, I guess, at all. In essence, two recursive types are equal if their infinite unfoldings are equal, or subtypes. So many smart points, they must have an important point, yeah. The tree model provides a clear and solid foundation for the interpretation of equirecursive type. Yeah, I guess. They also provided a rule-based axiomization to compare equirecursive types as shown in figure 1. They proved the soundness and completeness of the rules. Okay, you know what? I think ChatGPT is like a little easier to understand. Let's see. Isorecursive types. Substitution is trivial. Yeah, I mean, okay, I guess I kind of like maybe understand equirecursive types. Substitution must be structural and guarded by a curse check. Okay, that's like my stuff. I'm doing the structural substitution. Yes. All right. The definition is describing the behavior of the equal with dot symbol. You think so? I don't know. We would need to ask some PhD, someone with a PhD. An equirecursive type is conceptually an infinite tree. Yes. Okay. So like the isorecursive types are not infinite trees, but I do have infinite trees, right? So my types are equirecursive, right? Whatever that means. And the U binding, what is this? The micro binding is just a compact way to represent it. So substitution must behave as if you were substituting into an infinite tree, but lazily and without blowing up. The algorithm is basically treat this as a node with a binder. When substituting for some variable x, if x is equal to t, stop. Bound variable, no substitution. Otherwise, recurse into t. Maintain a visited set pairs. So if you revisit a recursive position, you don't keep expanding. This prevents infinite descent. That's what I'm doing. Use a regular tree representation, not literal infinite trees. Your type graph stays finite because you memorize subtrees. Yes. Substitution should rebuild these nodes. Yes. A current check protects you from nonsense. So like the problem is when I combine this with okay, so with equirecursive types, how do I substitute something that's not inferred yet? That's the question. You do not need the thing to be inferred before substitution, even with accurate recursive types. Is that true? So they're saying that I don't need them to be inferred at all? But if I don't infer them, that I don't know nothing about them, so I don't know if the substitution is the same type or a different type at all, right? So waiting the answer before you start the game. HM style inference is the process that reveals the answers. Here's the core truth. With equirecursive type, substitution works on unknowns just fine. Unknown type variables, unification variables, are perfectly legal substitution targets. They are nodes in your type tree, not missing information. A type variable is not inferred. It's a placeholder that will be unified later, yes. If you can substitute into it, replace it, inspect it, whatever, it's just another type node. How substitution node works with unknowns. Your type nodes look like this. The base type constructor, unknown variable, recursive binder. So when substituting this, you do that. Even if S contains some unknowns, that's fine. They are part of the structure. You'll unify later. Beeping gets aggressive. Beep, 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 beep. Is it gone yet? But what about recursion? Equirecursion only affects one thing. Your substitution must avoid infinite expansion. Okay, so I guess like this was already solved, right? But wait. Okay. This doesn't answer my question. So what exactly do I replace the not inferred variable with when performing substitution? It can either since it can be unified with the variable that was supposed to be substituted. Read last phrase, lol. My own, their phrase? And your life would be 1000 times easier if you just used Rust instead, where the type checker would grant you at you until you behaved. You mean that? You replace it with the actual thing you're substituting, even if that thing still has a known in it, and let your unification later. Smash everything together like two grocery carts colliding in a parking lot. The variable not yet inferred problem is not a problem. But that's exactly what I was doing previously. If I have something that's not inferred, then I'm like keeping it the same variable, but that is wrong. But they say that it's right. Okay, so let's... Okay. Hold on. Does that work in languages with dependent types? Does the substitute unknowns first, unify later trick still works? Yes, but only if your dependent type theory is sane, and many are not. And that is why every dependent type system either restricts one can't appear in types, or forces you to normalize, or requires annotations to avoid chaos, or makes unification deliberately weak, or all of the above. But the core principle is the same. Unknowns are allowed to exist in types, and substitution does not require them to be solved first. So I'm trying to do... So ChatGPT keeps insisting on the fact that what I'm trying to do is wrong, and no one is doing it like this. Right? So, okay, let's open up Idris or something. You say Lean has a good language server? Can I try Nerdsel? You know Lean, right? Let's try Lean a little bit. You didn't do any complicated stuff in it. You know what? How about we just copy whatever Nerdsel was doing? Let's take a look at Nerdsel. Nerdsel. Is it Advent of Code? Where's your repository? Advent of Code a year ago? Advent of Lean? Sure, let's open this. Like, you did it with a Flake already, right? You were using Nix. Nice, good. Let's go to Advent of Lean. Download the thing. Do I need to do anything with Helix so that the language server works, or does Helix come up like just work out of the box? What did you use as an editor? I mean, let's see what's here in the flake. You just have the Lean 4 installed, that's it, right? Which probably is enough, I'm guessing. You don't have .helix here, so maybe you configured your own one. Nerdcell. Do you have Nix files too? Is that what you call it? Your dot files? Last month. Let's see, home. Helix. Languages. Godot? Huh? GDScript, Haskell. Rai. Scala, Rune, Rock. There's no Lean there. Why is it so slow to download something from the NixOS cache? Just that package and Helix picks it up from the path? Okay, nice. So we'll just try Helix then here. And what am I even trying to figure out here? What am I even trying to figure out? I don't even know what I'm going to write. What am I trying to write? Let's go back to my playground. I mean, basically the same thing, right? Is what I want to do. How does Lean do this? So in Lean, this would be just a function returning a type, right? I'm assuming a generic type is just a function returning a type, right? Let's open Lean language. Boom, beam, boom, beam, boom, beam, bum. There's playground. I don't even need to download anything. Waiting for Lean server to start. Okay. How do I write code now in this language? How do you run? Def? Is def for functions? Colon equal? Well, to infer the type definition of f. Fail to infer the type of binder X. That makes sense. So unlike Haskell, this does not do let polymorphism, right? Where this must be some concrete type. Okay. That makes sense. But if I try to call function f using an integer, unknown identifier f. Do I need to do like semicolon here or something? Oh my god. Let's take a look at some code. Wait, where's the old code, Nerdcell? Oh, over here, Advent of Lean. Day 1. You define a function, you define its type, then you have some pattern matching, I guess. Sure. Or a colon equal. What's wrong here? It says unknown identifier F. It's supposed to work, right? Oh no, I don't want to spend the entire stream trying to learn the language. Why is this not compiling, Nerdcell? Or maybe the F is not is unknown because it cannot figure out what's the type of it. Is Lean's inference actually bad? So like I need to specify the type here. So this function F, and then it takes n, which is like a natural number. And now we know what F is. Oh, wait, what? That's really bad though. So in Lean, you cannot use a function unless you know its type? Is that true? How do you ignore the thing? Hello, TBD, etc. One last bug. Yeah. This one last bug is big though, so I'm like trying to figure out how other languages do the things. I'm downloading more Lean. Maybe you can just ignore. It's unknown identifier. How do you do a variable? Can we do a let this be this? Except colon equal in unit semicolon main must have type list string. Okay, yeah, let's just call it main2, I guess, and then it should work, right? So we can do a let and then we return nothing, right? Sure, so that works. So you're saying that Lean cannot infer this, and because it cannot infer it, so like Lean must infer the function definition at the definition. Is this maybe only for the defs and not for the lets? Can I do a let fx to be equal to x? There we go. And then f is net into net. It can do inference for lets, but not for defs. Whatever, like, I don't know why. All right. So what's next? What do I try here? I'm trying to create the function that is called a list, right? So we try to create a list type, right? So list is taking t, which is type. Do we have types? And this returns type equal to t. Can I do that? Unknown identifier type. Is there like type like that maybe? There we go. Okay, unused variable list. Okay, but can I define a type with a let? Let's learn the language really quickly. Theory improving mathematics, Lean language reference. Type classes. I just want the type system, right? In addition to having types, terms also have related by definitional equality. This is mechanically checkable relation that's tactically equal terms modulo their computational behavior. Ah, inductive types. Or maybe you can wait, or maybe you cannot do a type. Can you not have a function? Okay, let's just ask ChatGPT. How to make a function that takes type and returns a list and returns a list of I don't know, and returns a pair of t returns a new type which is a pair of t and the result type itself. So it's like a recursive list in Lean. Can I do that? Lean cannot conjure a new type inside a function the way I wish. You define a type constructor instead. So have an inductive constructor. So it's different from a function, right? A little bit. Can you explain the problem so in a way you would understand? I was trying to do that. So okay, so we're doing the inference, right? We're doing the inference, right? I want this to work, right? This is a type. This is a generic type, right? We have a generic thing which takes type as an argument. Type t is the argument of my generic, right? And this thing is returning the type where the head is of type t and the tail is the type itself, right? So this is a recursive infinite list, right? This is a recursive type, which is an infinite list of t's, basically, right? If I added another constructor, that would be like not a recursive one. So what we want to do is to figure out we want to figure out what is a list int 32, right? We just want to figure out what is this type, right? So how do we do that? A generic is basically just a function, so I'm trying to evaluate this. But this thing is recursive, so while evaluating this, I want to evaluate this thing itself. That's a separate thing. Yeah, I need to like figure out how to formulate my problem even, right? Maybe it's when I have a function. So I have a function create list, right? A function create list, which takes t, and there should be a function that takes nothing and returns the list of t's, right? Yeah, I have these annoying type annotations. Let's go back to VS Code then, I suppose. This is the code, right? I'm trying to figure out what is the type of create int32, right? Create int32, the type of this should be unit into list of int32, right? That's what it should be, because t is equal to int32, right? Right. Because I compiled the body of this function once, the type is still just list t, right? Right. What I'm trying to do is I'm trying to replace t with int32. So I'm substituting the bindings. That's what they were talking about to me, like the ChatGPT said, right? We do the substitution and we replace all the type variables with the new variables, and in this case I already have the value for it, so I'm just replacing it with the concrete value. So I need to replace all t's with int32. But sometimes I don't know what this thing is yet. Why do I not know what this is yet? There can be multiple reasons. But like if I don't specify this type here explicitly, then this type should be inferred based on the function body, right? And there, like, it can wait for other things to happen before the thing is inferred, right? So let's say that for now we don't know that this function returns a list t, but we just know that this function returns something, right? This is some variable. So so what should happen if I don't know the return type of this thing yet? So ChatGPT told me that I should not replace it with anything. Which means that it's going to be the original type. But then later I will figure out that the type is list t. So like I will say that this type, so this is some variable. I will say that this is some variable, right? I have not replaced the t with integer because this is an inference variable which is not known yet, right? And then later we will actually unify it with the body type, right? And the body type was inferred to be list of t's, and this is how we basically leak the t into the outside, because the substitution already happened, right? The substitution already happened. So I no longer am trying to so like, because I'm unifying this thing becomes list t, and since this is the same variable, this becomes list t, and this is not a list int32. This is a list t now, right? Which is wrong. Right? This doesn't seem specific to recursive types. Yeah, I guess it doesn't, but like, yeah, this doesn't seem to be specific to recursive types. Yeah. Maybe we can figure out some like example of how would I how I would do that, right? Yeah, how about this? So we have a function. Yeah, let's get rid of the types, right? Let's have just function foo, which is a generic over t, and it's a function that is it's supposed to return t, right? It's supposed to return t. So then I call foo with int32. This is supposed to be an integer, right? And then let's say that the body of this function is going to be. And then let's say that the body of this function is something like this. Let x of type t be equal to whatever, you know, and then we return x, for example, like something. But then, before this actually happens, I need this to wait a little bit. So let's say that all of this is happening inside of a recursive scope, because I need to wait before this function can be compiled. And then I'm going to say that I'm just going to call the function function defined later, for example. This over here is going to be module. This function defined later is going to be equal to a function that does nothing, you know? How about I need to stash or whatever my current changes. I want to go back to some version that worked of my language. I think I can just commit this one. Except I'm going to replace all log infos. Maybe back with traces. Okay, yeah, because this is basically only substitute when calling functions, right? And then I think this can be reversed. Let's see what's going to happen. Cast run examples. Hello. Type check failed. A unit into the function that returns itself is not equal to int32 over here. Yeah, because this is actually a function, right? So this should be a function that returns int32, right? Okay, wait, hold on, this actually worked. There's no way this worked. Hold on, why does this work? Why does this work? Let's open cast language server. Let's, I don't know, reload the window. Okay, we have the type thing works. Okay, so the foo is the function, generic function that returns t. This function is defined later. Oh, it's because I written this here, right? Let's see what happens if this is, I want this to be inferred, right? To be t. There we go. Okay. Wait, this works? Wait, what? Why does this work? Oh no. I cannot even make this simpler thing. Remove int32 from where? From here? It knows that this is an int32, but why does it know that? Why does it know that? I have no idea, actually. Cast is finally smarter than me. Yeah. Why does it... Wait, so, okay. Maybe ChatGPT just right, and I just don't understand something here. What if I don't say that this is that? Then it doesn't know what the type is. And the type is equal to this type too, right? Line 5. Oh, no. It's not equal to the line 9. No, I mean, yeah, yeah. No. It's the same type that we... Okay. Hold on. What? So maybe I just don't need to fix anything. How does this work? I need to understand how this works right now. Let's do this. Let's do comp time. DBG print. Cool. It's a binding foo. Wait, is the problem because of it can be if it is a const? No, there's no way. You don't quite understand why it was supposed to not work? Okay, so the thing is, so how I imagine this should have been working, right? I'm trying to compile this function, right? So this is a function returning a function, right? This is a function returning a function. So this function that we are returning from a generic is a function that is returning some type, which is originally not inferred, and we only finish... Oh, I think I know why, because over here the int... I think I know why. Because what is this int? Let's try this. Native int32. Maybe this is going to break it. Is this breaking it? Oh, there you go. It's broken. Okay, nice. Okay. So native int32 is in an int32, right? Yes. So int32 is native int32, right? Like there was a little bit of a different thing, which changed the order of the inference, but now I have actually figured it out. All right. Don't worry about that, right? It just changes the order a little bit. So as you can see, the type here is unit into t, right? Now it's not unit into int32, which is the correct answer. The type is unit into t. So why is that, right? Let's think about what's happening here. I'm trying to... so like, what we say is that this returns some variable 1, right? So variable 1 is something, right? So what is variable 1? It's a type. What type is it? What type is it? Because so this should return actually t because of the definition of this function, right? But we don't know it immediately, right? So what happens first? First, we figure out that the type of foo t is still just so it's supposed to be like var1, or it's supposed to be like unit, which is function taking unit returning var1, but where t is equal to int32, right? That's what we do, right? That is the substitution that I'm supposed to do. But we don't know that what variable 1 is actually equal to yet, right? So at this point, we only know this information. Right? So at this point, we think, so type of this is equal to just unit into var1 at this point. And then after this is defined, I can finish this compilation, and we actually infer the type of this function, and we infer that this function is returning t, right? So we basically say over here something like variable 1 is equal to t, right? But which basically says that the type of this is unit into t, right? You see how this step where t is substituted with an integer is skipped? Because I couldn't do it immediately. That's the bug. Does that make sense? I mean, go get myself a drink. Are you listening, Nerdsoul? Do you understand it or not? So we like, you got distracted? Oh my god. Okay. Basically, the sequence of actions is something like this. We so foo is the thing that takes t and returns a function, right? This returns a function that takes as an argument unit and returns some variable 1, right? Yeah, like it is a generic, but like let's just say that it's the variables, right? So this is some variable 1. Then because I don't know what this is yet, and like we're supposed to be order independent anyway, right? So let's figure out what is function foo applied with the integer as an argument, right? So the function of the type of this is basically unit into var1, but we need to replace t to be equal to int32, right? That's how we apply a function. We take the definition of the function body and we replace the argument with the actual value, right? Okay. So then later we actually figure out that the definition of the function body is that it's returning t, right? So we are saying that variable 1 is equal to t. So so this means so basically what happens, like, because this is the series of actions that we have done, like we have only 3 actions, right? So in this action we could not replace t with an integer immediately. So we just say that the type of this is just unit into variable 1. But now that variable 1 is equal to t, we get the fact that foo int32 is just unit into t, right? So now foo int32 is of type this into t, because we did not replace it immediately, right? But t doesn't even exist in this scope. T should have been replaced, but because we couldn't do it immediately, it has now been leaked. And that's the bug that I have right now, okay? So ChatGPT is telling me that in the Hindley-Milner type inference, I'm supposed to do exactly as I'm doing right now. But it seems like it's not working. So there is something special about my language which lets this bug to happen. Maybe like it's like I cannot do I cannot make the like I don't know. I don't know though. Like it's weird. You know? Like I should be able to have like the same series of inferences, right? To be happening in the same order in other languages too, right? I think. So what I was thinking that I should do is that when I'm replacing this, what should happen actually, right? I remember basically no, I don't remember the fact that I replace it. Basically, what my theory was that when we want to replace this, what I want to do is actually I want to replace it with a new variable. So we replace it with variable 2, right? But once the variable 1 is inferred, then we actually perform the replacement, right? So now that variable 1 is equal to this, now we say that variable 2, because of that, now it's equal to int32, and now we know that this type is correct. That is my theory. That's what I was trying to do. But ChatGPT, maybe ChatGPT is just hallucinating also, right? That's another thing that could happen. But it's very like it's trying to not agree with me. It's trying to say that I'm wrong. You know? And that you don't do that in the Hindley-Milner and like whatever things. ChatGPT disagreeing is a rare occurrence. Yeah. Which is why I'm trying to like believe that it's true, right? But now I need to like if it's true, then unknowns are still substituted before being inferred, right? That's what ChatGPT is like insisting on. But they are being substituted with the thing that they already are, which is later being substituted with the variable. So there is something like maybe something that's wrong about my algorithm or whatever, but it's weird. Can you link to the simplest explanation of a substitution? Can you substitute with the literal variable 1 where t is equal to int32? Well, that's kind of what I'm doing actually, right? I mean, that's what I was trying to do. I never implemented that because I have some infinite recursion. We can try writing that code again. That's what I want to do, yes. It's just like weird that ChatGPT tells me that's then not what I'm supposed to do. Also. Yes, that's what I'm trying to do, right? That's what I think I should do. Substitution in the lambda calculus. I want to see how someone is substituting an inference variable that's not inferred yet. Show inference plus unification, substitution plus unification examples to show exactly how type variable isn't inferred yet gets substituted and then later unified. Yeah, that's what I want. Type inference with type variables and unification from a programming language course. I mean course, not curse. Feels like a curse. This walks you through a simple example where two types containing type variables unify producing a substitution that replaces some unknowns. The curse is real. Is there anyone in chat who has implemented the type inference with polymorphic types, I guess? So we need polymorphism, unification. Yeah. You just watch because it's interesting? Alright. It's interesting to see how I am achieving nothing in 2 hours of stream already. Alright. Thank you. I'm glad to be of entertaining value for you. Does Eduardo know? I don't know. Is he streaming right now? I don't know. I'll just read the fucking manual of the like type theory or something, maybe. I don't know. I mean, he knows stuff for sure. But can he explain it simply? That's the question. From my experience, ChatGPT seems to know a lot, but when it comes to solutions, it never works. Yeah. I mean, maybe like the solution that I have in mind is correct, but like I'm just being misled right now. But I kind of okay. This one is short. Let's read this. Motivation. I hate how hard type theory can be to get into. Okay, I like this beginning. This is really good. Okay, and this is really short. Okay, let's see. I've recently been fiddling with Hindley-Miller type systems and wanted to write down some notes that are hopefully understandable to future me. If they are of use to anyone, cool. But if not, also cool. I will definitely be referring to them in the future. A Hindley-Miller type system is essentially an extension of type-limited calculus with parametric polymorphism. This polymorphism is usually implicit and can be importantly only used at the top level. Is it because I allow it to be used not only at the top level? Maybe that's why I'm having the issue or something? I don't know. It has some extremely nice properties, such as type of any term being inferable from its use, and a fairly simple, almost built-in method for inferring set types. Types of types. Hindley-Miller deals with two kinds of types, monotypes and polytypes, aka type schemes. Monotypes are simple non-polymorphic types such as integer, boolean, a listage or string, and so on. For simplicity, I'll write concrete monotypes with uppercase first letter and type variables with lower. Polytypes or type schemes are universally quantified monotypes, such as for all A, list A. Okay, so this is like a type function, right? Yeah. Okay, sure. Which is concretely the type of a generic list. Or for all A into A, which represent the type of an identity function. Okay, nice. I don't call them polytypes. That's a weird name. Monotype. Yeah, whatever. Instantiation and generalization. We can convert between monotypes and polytypes using instantiation. Apparently, the problem is not with recursive types. Yes. Did you ask Eduardo something? The problem is not with the... Yeah, I think the problem is not the recursive types here. Right? Because this over here doesn't have recursive types. The example that I have here. The problem is the order of inference. Yes. Nigel? Yeah. Why are you still looking at Hindley-Miller when... Yeah. Yeah, we have this simplified example which doesn't work. He was busy? Okay, fine, let's do it again. Maybe if I explain the problem 1,000 times in a stream, I will finally understand it properly myself and I will understand the fix. But yeah. Let's just do this. It's very simple. It's very simple, actually, right? let's say that the function foo, as defined over here, function foo is a generic function that returns this x of type t, right? So it's a function that is returning t, but I'm not writing this here because we don't know it yet. In order to know that the function, in order to like infer the fact that this function returns t, we need to like finish looking up like and inferring the things in the body of the function, right? So for now, we don't know what this function returns. So let's say that it returns variable 1, right? So we know that function foo, if I replace the generics with just being functions, it's a function that takes t and returns a function that takes unit and returns variable 1, right? When I'm trying to instantiate this generic with an integer, as an example, what should happen? So we basically call this function with t being equal to int32, right? So the type of the result is unit into the same variable 1, but we need to replace t with an integer, right? That makes sense. But we don't know that variable 1 is t yet. So what I was told by the ChatGPT, it was very insisting that I should not replace it with anything and I should keep it as is. Which means that this replacing of t with int32 should not even happen. So I keep it the original variable 1. So the type of foo int32 is just the thing that returns variable 1. And then later, I actually like finish compiling the body of the function and even figure out that this function was returning t. And now because this was returning t, we have decided that foo int32 is returning t, right? Because it's equal to the variable 1, and variable 1 is t. Because now we lost the information that t was supposed to be replaced with an integer. Because of the order of inferences, right? Because the order matters. And we have a bug where t escapes the scope. So this is another, like, this is kind of like a scope escape. So it's a very like similar problem to the scope escapes that we were discussing the other day, right? But in this case, the reason it's escaping because it's not being substituted properly. So this is supposed to be just int32 here. Does that make sense? Did I explain it well enough this time? In algorithm W, the type of foo would always be known before it's instantiated. So is that like... But how... Okay, in algorithm, the foo would always be known before it's instantiated. Okay, yeah. I guess that makes sense. So that's why we were trying to wait for the types to be inferred before substituting, right? But you cannot always know that. Like, specifically in algorithm W, you can always know it or something before instantiating. Why is an algorithm called W? I don't remember why. Is it a win? Okay, instantiation takes the polytypes and returns a monotype by removing the quantifier and replacing all usages with some monotype. Yes, if everything was already like inferred, then it would be trivial, yes. But then I have a deadlock. So how does algorithm W not have a deadlock? That's the question, right? And algorithm W doesn't have a deadlock because it doesn't have recursive types. Okay. Okay. So what's the algorithm that is used in the languages which have recursive types? It's not the algorithm W then, right? It's some other algorithm. Is Hindley-Milner not the W? I have no idea. All right. Let me just read this. This seems like a nice article so far. Let me finish. So when we instantiate, we'll replace all usages, right? For example, for all a into a should be instantiated to either integer, or bool. Okay, that makes sense, right? That's what we're trying to do, but this thing can contain the not inferred variables. That's the problem that I have. Generalization takes in monotype and returns a polytype by quantifying over all 3 type variables in the monotype. That's for the let polymorphism, which I'm not doing, at least yet. More importantly, the types A and for all A are different. The former represents some concrete type, which we don't know yet, so it must refer to the variable. Okay. Hindley-Milner only allows a universal quantification of types at the topmost layer. For example, any polytype must have the form for all variables type with no nesting of the quantifiers. What's a quantifier? The for all? This, as far as I understand, makes the type system decidable as opposed to the type system dubbed system F. Oh, maybe like, so we need to look at system F, right? Which is different, which does not have this restriction. Although, like in my specific example, I don't have the nested quantifiers in the example that I am having right now. Reading inference rules. The meet of Hindley-Milner can be specified considerably with a small set of inference rules. This looks scary, but are fairly straightforward once you understand how to read them. Every inference rule has a set of premises and a conclusion, which are put on top and the bottom of the horizontal bar, like so. If we know P and Q, then we know that P and Q. Okay. When dealing with actual type theoretic inference, we often carry around an environment use resolution as like, how do you even pronounce this? Gamma? The environment contains all the types of terms that we have already inferred. Really, it is just a set of terms and their corresponding types. The main operation we do on the environment is to make statements like gamma, this symbol x is tau, which means given the information in the environment, we know x is of type tau. This is called the typing judgment. This operator called the turnstile can be thought of as a statement stating that a proof exists. Concretely, gamma turnstile A means that given gamma the environment, we can prove A, whatever that might be. Inference rules for basic and limited variable usage. The first rule describes how to assign types to usages of variables. It's written as this. If we know that x is of type t, what? In English, if the environment actually contains the information that x is of type t, that the environment proves that x is of type t. Okay, whatever. Stating the obvious. Function application. Okay, so now we know that function f is t1 into t2 and a is t1. Now we know that fa is t2. Okay, that is easy. Okay, does it help me? Maybe let's go here. When actually performing inference, unification is a process that often comes up. Unification is a process that takes an input 2 types and returns a substitution that when applied to either type will make the 2 types equal. We use unification whenever we want to constrain 2 inferred types. See program lava. Hello. How are you doing? Substitution is the list of bindings from names to concrete types. It can be applied to any structure containing types, which will replace the type variables in set type and the type in their entry of the substitution where applicable. That's not what I'm doing, actually. I guess I'm doing it in place. And this is more like a functional immutable way of doing things where it returns the substitution, but okay. The typical algorithm for unifying two types is fairly simple, written below is F# code. So we unify two types. Yeah, like what I'm doing is I'm just saying that these two types are equal and that's it. And I'm like mutating them. What happened to my language? I'm trying to like explore the theory a little bit because I need to fix a problem in my language. If foo was a function X into body, the Miller type of foo is let return type additional type substitutions is type of body X new monotype. This is just a function, so no polymorphism. Yeah, in Hindley-Milner, the polymorphism is implicit, so because like it could not infer the type of X, it remains a free variable, and they do the generalization, which turns it into the polymorphic function, as far as I understand, using like the let polymorphism. This is the typical algorithm. Match T1 and T2 with A when they are equal, then it's empty. If it's type variable A and B, when not occurs AB. When A does not occur in B. In English, this roughly means if the two types are the same, it yields the empty substitution. If either type is a type variable and does not occur in the other type, return a substitution binding the type variable to the other type. Okay, if we're unifying two, unify the rest type and each function type. If we are unifying two function types, unify the first type, apply the result substitution to the second type and the resulting, and then unify those, combine two and return that. All other cases fail to unify. This indicates a type error in the program. English translation of what I sent. You get the type of the body first with X having a new type variable assigned to it, and then the type of the function is that new type variable substituted with any substitutions. The type of the function is that new type variable substituted with any substitution. When does the substitution happen? I mean, that's what I'm doing, right? That's what I'm doing. That's why I was writing this here. This is a variable, right? This is a new variable. That's why I'm writing it here. So because I have not specified this, I introduce a new type variable, and that's the type of X here, right? And then I want to substitute it when I'm actually... inferring the type of body might give us more substitutions. Yeah, but inferring like but what if I cannot infer the type body immediately? Right? That's what's happening here. I'm like, before I can like infer the type of the body, I need to look at something in the future, because this is using like in this case I do it by using some function defined further. Did I start to write my language from scratch? No, I didn't. I'm continuing. I'm having a bug that I'm trying to fix. in the type inference. In Hindley-Milner, function defined later should not be allowed. How do you write recursive functions? Can you not? Oh, I guess in Hindley-Milner you cannot. Wait, in Hindley-Milner you cannot do recursive functions. You don't have recursive types. You don't have recursive functions, right? Okay. Yeah, I mean that simplifies things for sure. Then why are they only? Why there are only few files in there? What do you mean? This is the files that are changed. This is all the files. This is the files that I changed. That's the change list for the Git, the source control stuff. This is all the files. We have a lot of files. We have 99 OCaml files right now with 12,000 lines of code. Which is actually not that much. That's a pretty small number. Okay, so Nigel, you have been learning the Hindley-Milner stuff, right? Have you looked into the more involved things? The system F, whatever? System F. Let's see what system F. System F, aka polymorphic lambda calculus or second order lambda calculus, is a typed lambda calculus that introduces to simply typed lambda calculus a mechanism of universal quantification over types. System F formalizes parametric polymorphism in programming languages, thus forming a theoretical basis for languages such as Haskell and ML. It was discovered by this, and that, where simply typed lambda calculus has variables ranging over terms and binaries for them. System F additionally has variables ranging over types and binaries for them. Okay, so like generic types, right? And System F is different. Whatever. You ended up not liking it. You prefer System F? Okay. So what's the difference between the Hindley-Milner and System F? I still don't know what is the algorithm that I have in my language. Do you understand what I have in my language now? What's the algorithm that Rust has? What's the algorithm that Haskell has? They say over here that it powers Haskell, right? System F. It's base for Haskell. System F has capital lambda to write type into term stuff. Hindley-Milner does not have that. Capital lambda to write type into term stuff. Yeah, which is like the generic types, right? Yeah, higher kinded. Can it be higher kinded types too here? This is the capital lambda. And this means that X is of type A, right? So this is basically this over here. Oh my god, I scrolled and I lost it. So this means over here that this is a generic function for all types A. We have a function taking the argument of X of type A and argument Y of type A and returning X. Right? Okay. Bam, 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 bam. This is easy to read. Okay, so how do you infer? Is System F also the inference algorithm? Well's result implies that type inference for System F is impossible. Okay, so what we're trying to do is we are trying to do the impossible. Am I right? A restriction of System F known as Hindley-Milner does have an easy type inference algorithm. But like I guess like what they say is the full type inference where you don't specify any types is impossible, like in general. But that's not our goal. Our goal is to infer like most of the types, and like we still can do manual type annotations, right? So like, and now our goal is not to do the full type inference of the entire program. Told you cast is too powerful. There is no theory beyond this point. Okay. System F corresponds to the first axis of the lambda cube. Oh no. System FW, or the higher order polymorphic lambda calculus, combines the first axis polymorphism with the second axis type operators. It's a different, more complex system. I have no idea what you guys talk about. Yeah, it's like some type theory. I have no idea. The Hindley-Milner is the inference algorithm. Have you tried any programming languages that is not C? So here's the. Let me give you some simple example, right? How is it different from inductive types, aka recursive types? Yeah, from a more basic type system. Yeah, maybe. Maybe we could learn something from Eduardo, but also I feel like technically I have the algorithm. Like, I feel like we should just stop looking into theoretical stuff. We should just do what we said we need to do in Nerdsel, which is we remember the fact that I wanted to replace, and then replace later once it's inferred. That's literally what we want to do, right? I think. But yeah, C program lover. Let me show you an example. So here's this is a Rust language, right? This is a language that is called Rust. So which is similar, kind of, right? We have a function f which takes argument x and returns x. This over here is syntax for a function that takes as an argument x and returns x. This is in this case a lambda, right? So so we don't know the type of it yet, right? We cannot infer. Type annotations are needed currently. But if I try to actually use this function, right, for example, f123, right, if I try to call this function with 123 later, then the function is inferred to be a function that takes an integer and returning an integer. So I don't need to provide the definition of the function immediately. It can be done later, right? In language like C++, you can only infer the types like if you know the function f, you can know what this function returns. The types, the type inference is like a little different, you know. I don't know if that makes sense, and if I can explain it easier. But this is the inference that complicates things a lot, I guess. So, yeah. Should look more into how TypeScript does recursive types. Does TypeScript do it somehow differently? I already have recursive types working. It's recursive generic types that are not working, right? Let me see if I maybe no. Never mind. Never mind. Let's just do this. Type list E is null in OR E and list E. Yes. Okay. So what does that mean? What does that give me? Possible in TypeScript. Okay. What? My my problem is that I need to figure out how to do the inference itself, right? Beep. Beep, beep, beep. All right. Let's just do this. Let's try to implement this substitution from scratch. From complete scratch. Let's just look into how TypeScript does it. Do you know how TypeScript does it? Okay, fine. No, you don't know? Okay, so why are you suggesting that then? We can look at any other language, right? Why TypeScript? Okay. So once again, when I try to substitute a variable that is not inferred yet, if I am trying to substitute, if my variable is not inferred yet, I mean, we can only do this original value. Because they don't have ADTs like Haskell and Camel and whatnot, so their implementation is easier. I don't know. Let me just try to do my own thing. First. So I did it yesterday, but I did it with a bug, I guess. So we had like this infinite recursion. Let's try to do it again. So I just want to delay the substitution until after the variable is inferred, right? Then that's all. So we are going. So we are going to initialize the substitution with a new not inferred variable, right? And then we say that variable inference variable once inferred. Once it is inferred, I'm going to do something, right? Once it is inferred, I'm just going to say that I need to do the substitution now, right? So I try to substitute the thing. What is state? That's an interpreter state, okay. Original value. What's original value? Just my original value. And shape. Wait, do I ever return original value? Substitute original row. This doesn't really matter here. I think original type. Yeah, whatever. So variable, once it is inferred, I'm trying to substitute this shape, and that is my substituted shape. Oh, Camel, I borrowed check, by the way. Hello, hello. Yeah, I'm writing OCaml. I'm writing my own language in OCaml. Hi. Do you like OCaml? Same. All right. Write your own systems language in OCaml as well. All right. My language is not really a systems programming language. It's a general purpose programming language. And I'm focusing on the high level aspects of it before going into low level. So right now I actually only have the interpreter, and I'm not even compiling it to machine code at all yet. It's that's planned though. Try to ensure it's a CFG as well. What's CFG? CFG language. Context-free grammar. Okay. But I think like that is only about the syntax. Syntax is something that's the doesn't really matter in my opinion as much as the other parts of the language. But if we talk about the syntax, my language has extensible syntax, which is powered by the macro system. This would make parsing semantic stuff a lot easier. That's the thing. You get rid of the fact that you don't want to make the parsing literal nightmare. C++ parsing, yeah. I don't know if my thing is context-free. I didn't really think about it, but my syntax is like it defined in the language itself. Something like this. Let me see. Rules of the syntax. Here's the syntax of my language. It feels very context-free. Yeah, maybe it's context-free here. So I define the syntaxes. I define priorities, and then like the keywords and stuff. You know. So it's like an expression language with priorities. That's all. Everything is an expression, and we just have different priorities for different syntactic constructs. That's it. And then this like this can be extended during parsing technically. So that makes the language extensible. If you can just add your own syntax, shouldn't it be context-free? Is there like a context-free completeness theorem or something? I don't even know what context-free means. I'm not really too much into the theory, which is maybe why I'm having like problems with inference currently. But the problem that I'm having right now, let's try to explain it to the borrow checker. Let's try to explain it to the borrow checker. You're still listening. I have a problem where, so here's what my language looks like, kind of, right now. We have a function foo. This is a generic function that takes nothing and returns t. The borrow checkers will just tell you to clone. Yeah, so, but how does this work, right? I'm inferring this function to return t because in this body, I have done something that returns t. What's up? Yeah, I was trying to explain to you the bug that I have. I didn't know that you left, but okay. I'm having a problem with the inference. Do you do the like Hindley-Milner or whatever, like this style inference, like, you know, OCaml and stuff? You do bidirectional Hindley-Milner. Okay, so here's the thing, right? The type of this function, this is a polymorphic function, right? In OCaml, you would write something like this. Foo is of type, for t, it's unit into t, right? something like that. In my language, it's written like this. Okay. So a polymorphic function. And then I'm trying to figure out what is the type of this polymorphic function where the polymorphic variable is instantiated, right? So I'm trying to do the instantiation of polymorphic functions, right? So when you do that, you're just supposed to replace all of your variables with the new type variables, or because I can do it explicitly, I can replace them with the concrete new types already, right? So the type of a foo instantiated with an integer is the type unit into t, where t is replaced with an integer. So it should be unit into integer, right? But my current inference says that the type here is still unit into t. So why is that happening, right? Because because like of the order of inference, I'm not inferring the type of foo to be unit into t, but like because I'm compiling this function like in the background or something, I don't know that it returns t immediately, right? I initialize this function to be some new type variable, right? So I don't know that this variable is equal to t yet. So when I'm trying to instantiate this, it might happen that I don't know that this t is t yet. This might be just some not inferred variable. So how am I supposed to substitute it? That is my problem. And what I have been doing so far is I have been just like, if I see a type variable that is not inferred yet, then I'm just keeping it as is. Is Cast ready for advent of code yet? As soon as I fix this one bug, this one last bug needs to be fixed, and then it's going to be ready. Yeah. But having like the place expressions would be kind of nice, maybe, so that it feels like the final language that I want to make. So yeah, the problem is trying to substitute the not inferred stuff. And what is bidirectional Hindley-Milner even? Is it not Hindley-Milner? Because I was told that Hindley-Milner doesn't support recursive types. Do you support recursive types? Bidirectional Hindley-Milner. He went away for 5 minutes. Now we will have a borrow checker itself in chat. What did I miss? Or do you mean like you do bidirectional type checking, which is like based on Hindley-Milner? How does Rust do it? Based on Hindley-Milner, so it. Okay, yeah, whatever. Yeah, so I'm doing something similar, and like I'm just wondering if you have the same problem then. Or do you not have the same problem? Do you have polymorphic functions or not? How does Rust do it? I mean, yeah, like all of these languages, like Rust, Haskell, OCaml, they all have like the same inference algorithm at its core. Although Rust requires the functions to be annotated with the types explicitly, so it has like it needs to do less work, I guess. Rust. All right, so currently my plan is just to see if this is not inferred yet, then I'm going to substitute it with a new type variable, and then once the original variable is substituted, then I'm going to substitute it later in time, and then I'm going to unify the new type variable with the result of the substitution. That's the idea. Bam, 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 bam. But my research says that that's not how other languages do it. But figuring out how exactly they do it is, I don't know, it's a lot of work. So I give up. I'm just trying to do my own thing. Pum, 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 pum. Subt temp. So yeah, when I'm substituting the variable, I'm creating a new variable, and I'm saying that the result of substitution is this new variable. And now once the original variable is inferred, I substitute that, and then I'm going to unify does it have recursive types, the language that Borrow is making. ML style rec. ML style, I guess, type, I mean, just the types that contain themselves. Yeah, just like a list, which is either an empty list or like whatever. Okay, infer, so I just say that substitute temp is, I need to infer this as subbed. No, that's not right. I just do inference variable unite subbed temp and subbed. I ignore the result. Why is everything red on the screen currently? What is the result, by the way? Result is this. So I want to remove this. Unite and the span, by the way. Oh, and using the inferring here, yeah. Like that. Unite. Remove this. Okay, why is everything red? Hello? Result. Unbound value result. Yes, I return just the subbed temp. Right? This definition has type, which is less general than value shape. Substitute shape. Oh my god. Substitute shape. Why can I not even go to the definition? Why is OCaml language server so bad? Can I complain about it again? Hillmiller doesn't even have type bindings, so I don't know how you would even begin making recursive types. Yeah, are you sure that you're doing Hindley-Milner? Because a lot of languages, they say Hindley-Milner, but it's not actually Hindley-Milner, apparently. I don't know, really. Much, because I don't know the theory myself. I only heard some things from some people, I guess. Subshape. Oh, we have subshape here. Subshape state. Value shape. Sure, that's correct. Wait, This is less general than this, because this only has a single variable. Subshape. B inference variable. Subtemp. Oh, because new not inferred is not a variable, right? Okay. Inference variable unite subbed. Yeah, we need over here to have say get variable subtemp and get variable subbed, I think. Right? There you go, finally. And where I'd have to think if I should support this or not, if it already isn't working. If not, then I'll just think of something else. It was more directed at Kuvi. This is what Haskell says its type system is. Let's see. Haskell's type system is system FC. System FW minus type lambdas plus ADTs, including existentials. All right. But that is inadequate to describe GADTs and associated types. So in 2006, we extended GHC to support system FC, which adds equality constraints and coercions. So so what's the type system? It's like a custom type inference system, basically, right? Which they can only describe in 3 paragraphs. Okay. So yeah, I guess I have something custom too then, is what we're going to say. Can you show a language example? Yeah, sure. You can pass the link in chat to whatever you have. And recursive types comes from ADTs. Yeah. Yeah, I'm just having a more like... Well, I mean, I do have ADTs, right? Yeah. But that's not what's giving me the recursive types. The recursive types come because I have a generic approach to generics, which is not unique to types. Kind of, right? No, the recursive types don't even need generics, right? Because they're not necessarily generics. The recursive types... Yeah, it has nothing to do with ADTs. I feel like these are just separate features for me, at least. This is why I'm saying look at TypeScript. Okay. Hold on. As soon as I'm... if I cannot make progress today, then I will maybe be looking into things more. Over here, once inferred. Small conceptual example. All right, let's see. Data value is case int val, case this, case that. All right. Data env vars, sure. So that's how you define the sum type. That's how you define just a normal struct. Data list is that. Okay. And this over here means a pointer or whatever, reference, something, right? You do that explicitly, so you don't do the auto boxing in your language, I'm assuming, since you have this symbol here. Right? So you have the unboxed language, more like Rust. Okay. Do you have the borrow checker? Because the definition doesn't include the lifetime variable? Or is it unsafe language like C? Def env lookup, name string, value, match env vars. Is this square brackets part of the match syntax? Because I don't really understand the need for the square brackets here. D-style, let's say, GC opt out. Okay, yeah. So it's a garbage collected language. Kind of like you would do the same in Golang too, I guess, right? You just say that it's a pointer to the list, and then it's garbage collected. But then you can opt out of it, and then it's unsafe if you opt out of the garbage collection. Mm. You rewrote your project from Rust to a Camel? Yes, I did. I did. But also, I rewrote it from OCaml to Rust before writing it in Rust. If you are not aware that this is... I started my project in OCaml, then I originated into Rust, and then I hit the compilation time issue in Rust, so I rewrote it back into OCaml. Return at env. So this is actually taking the reference to a variable. I wonder why don't you use the same symbol here and here. But that's just syntactic stuff, which doesn't really matter, I suppose. You use colon equal for assigning. Or what about mutation? Do you even have mutation, or is it just an immutable language? Left arrow is variable mutation. Is it here? There is no example here, I suppose. Yeah, okay. Sure. Yeah, I was thinking of doing left arrow too for mutation, but I don't know how I feel about that. It's a little weird. And the reason I feel like it's weird is because like there is the symmetric thing, which is the right arrow, which is the definition of the function type. You use the right arrow to say something completely opposite, which makes it weird for me. In my opinion, that's why I just use the normal equal sign. But yeah, yeah. I mean, like it just looks like a language. Yeah, just only the syntax is what I can discuss here for now. But I mean, you have the sum types, which is good. Every language should have that. All right. I also think that over here I should fork or something with a recurse cache with cache action. Let's see. I feel like I just did literally the same as I did yesterday, and it's not going to work. Yeah, we have an infinite loop again, right? Let's do it here. Log inform log subbing variable ID. Yes, I am literally back to where I started in the beginning of today's stream. All right, so I need to like figure out what is this new variable that I'm creating. How about I say over here log inform created new variable this ID print inference variable recurse ID of get variable sub temp cyclical progress. I'm substituting the variable this, then I'm creating a new variable this, but then I'm subbing like there's another variable, one more variable that has been created new variable over here. Wait. And then this has been subbed. I have a loop. Okay. How to make progress and not be in an infinite loop. Inference var recurse id of get var subbed temp, so that I make sure that I don't. Oh wait, I understand though. That's not enough. Oh wait, I was like here subbed id. I was right here earlier today, and then I forgot. I understand now because I need to enter the into the cache too. The subbed ID, where subbed ID is going to work right now. Look, please work. A crash now, beautiful. Fatal exception not found. Okay, so I hold on. I think I understand though. This is how I do memory. Let's take a look. Memory management. Variable x integer is 42. Pointer is this. Value int is ptr. Oh, this is the dereferencing. Oh, I see. The square brackets are dereferencing. That's why it was in the match there, right? Yeah, and then you dereference this. Okay, sure. Move 4 bytes. What does move 4 bytes even mean? It's like just pointer arithmetics, I guess. Move in which direction? Byte offset. Okay, so like plus. Okay. Okay, sure. Yeah, that's just syntax. But the semantically seems like just a normal language, like. Well, I mean, you do the pointer arithmetics, which is something that is very weird and should not be possible in a garbage collected language. How do you garbage collect when you allow pointer arithmetics? That's the question. You turn off GC and only then you can do the pointer arithmetics. Yeah, that would make that makes sense. Maybe. But you turn off the GC for the entire program, or can you turn it off only for certain parts of the program? As far as you said, like D, I think D just does it globally, right? You can do attributes. My idea might be to use unsaved blocks, maybe the C# way. Okay. Boom, 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 boom. Okay, I know what's happening. We are panicking. We are having the hash table thing. Substitute type. This fails, and the stack traces in OCaml are horrible. They never point in the actual line that throws an error. The actual line is this one, I'm pretty sure. Let's do over here a find opt. I'm just going to match this with some sub. Then we do that, and if none, then I'm going to fail, saying that I failed to find subbed variable. Like, yeah, that's where we should be. Failed to find subbed variable. There we go. I know how the Y Combinator can do term level recursion in lambda calculus, but I don't know how garbage collection works. There is a lot of different ways to do garbage collection. Yes, arc and sweep. I think should be pretty easy to understand, no? There's a simple garbage collector for Rust. Simple tracing garbage collector. Let's see how big this is. There's some 300 lines of code here. And like 300, 400 lines of code here. And a lot of that. And this is just, I don't know. Seems like this is around 2,000 lines of code, this library. Maybe 3,000. I feel like it's possible to find the smaller implementation. But yeah, I never did it myself either, so yeah. But I think I would be able to do it as some garbage collector from scratch without trying it before. Okay, so what's happening here, right? What's happening here is that I'm trying to find the substitution. But then I clear the substitutions because now I'm doing it not immediately, but a little later. Okay. So what I need to do is I need to not clear, but I need this to be threaded through the thing. I can do it through the effect system maybe. Let's do try. Or let's do implementation with subs #table create 0. Let's do that. And then we do something like this. So I don't do subbed vars at all. Instead do type subbed vars is this type. And we do that with subbed vars subbed vars function unit into unit is try, call the function with effect get vars. Alternatively, I could drop GC and just let people use the STL arena record type and go well with that, but that would be a bad idea. My idea is to have the borrow checker. Why are you don't like the borrow checker? You named yourself borrow checker and you're not going to do the borrow checker for your own language? I'm going to have a little bit of a different way of doing it than Rust, but I am building on the Rust as a foundation. So I'm expecting to allow more code. My idea is based on the ghost cell, if you have seen that. You separate data from permissions and then combine that with an effect system, which will which is supposed to be nice. Yeah. Effect plus equal. My name was when I was still using Rust, but unfortunately I cannot rename myself, or else I ruined the recognition. Yeah. Yeah. I still think that Rust borrow checker is a good thing, though. but it can be improved for sure to be less annoying prick, as you say. Get vars is sub vars effect t. Okay, so if we have the effect get vars continuation, then I'm going to continue continuation using vars. There we go. That's this simple thing. And then, so instead of subbed vars, over here, there's going to be subbed vars. I'm going to say that subbed vars is effect perform get vars. Beep. It's happening very often today, is it? I don't know how to fix it. Sorry. I should try using a different mic. Maybe. Like, maybe it's a problem with this mic. That would be very weird, though. Buy a new mic. I do have a new mic. I have a mic on my thing. Purchase. CPU. USB composite. 1, 2, 3. Like, how do I use the microphone from the web camera? I cannot select it in the OBS for some reason. But I don't think it's a microphone. It's probably some software issue, because these issues happened when I switched to Linux, Nerdcell. It was never an issue on Windows, when I was streaming on Windows. How long ago was that? 2 years? 3 years? So I've been having this issue for 3 years. I think. You don't remember it being an issue? Maybe just more of an issue because I updated my Linux. If it, like, it's kind of like sensitive to maybe like the kernel and stuff. It's a Linux issue. Maybe like Wayland, like Hyperland, like no, not Hyperland. Like pipe wire plumber, those things. Maybe I'm turning his computer. Maybe. The value impulse value has type this, but expression was type of unit. Wait, what? Result is unit. Why is that? With cache, with subbed. Oh, because this should return A, and this should work for all A's, right? Yeah. Like this, type A. Dun 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 dun. Dun 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 dun. Let's see if this is going to work. It's not going to work. What is it going to tell me? It's going to say unhandled effect get vars. And that's happening for the same reason. That's over here. I need to do with subbed subbed vars function into this. This becomes a little annoying, but so like the problem is that I'm actually using the callback system here, but if I actually used the await inferred function, then all of my current effect handlers would be reinstalled, right? So maybe that's what I should be doing. Or I don't know, something. I don't know. I understand though why now sometimes I don't have the handler for an effect. Exception, this is not supposed to fail since subtemp is inferred for the first time. Okay, I have something that is supposed to not failed. This is not supposed to fail since subtemp is inferred for the first time. Okay. Yeah, actually that is right. Now this can fail. Now this can fail. It could not fail previously, but now since I'm doing it later, it could be like unified with something else. Okay. So now I need to tell it how to unify the things, right? I feel like all of these variables should be replaced with like a module type. Let's do something like this. I will have let's do this. I will have a module type, you know, inferable. Inferable, which should have a new not inferred, which takes this span and returns yeah, then we have type T. Then we have oh, but I cannot because I cannot do that. Oh my god, Camel is kind of annoying. Again, I cannot create the module because these are recursive functions where I'm supposed to use that module. So I need to like inline all of the things, and I cannot group them into a single type. Oh my god. Okay, sure. So what I need to do here is, since substituting the variable is potentially going to do the unification of the variables, I need to know how to unify the variables too, in addition to all these other things, right? So I need to have a unite. And unite is shape. It's shape. Yeah, unite shape is what I want. It's shape inference unite. Now I need to pass this everywhere, and over here instead of this I'm going to say unite shape. All right, now I need to pass this through everywhere. So in order to substitute the row, I also need to substitute. I need to know how to unite the shape. Unite the shape is going to be row unite. Shape using unite value. So I need to unite value here, which is a inference unite. Okay. And all of this is needed because OCaml doesn't have traits, by the way. So annoying. So verbose. So fast. Yeah, but by the way, traits is another thing because of which we would need monomorphization, I guess. That's why Haskell needs monomorphizations. Because the implementation of the trait of a type class is different. Can you write a program in your language? I want to see how it is. Let me show it to you right now. Hold on. Guess a number. Here is the program that is called guess a number. Here's my playground. I'm just going to paste this code here, and I'm going to share this. And this is going to create the link that I can put in chat, and you can look at this code yourself. And you can click run, and you can play the guessing number game in your browser. in my online playground, right? And you can try changing the code here if you want, but yeah, that's the example of the language. This is the only part that is being ignored currently, the with IO. This is supposed to be like the effect context system that is not implemented yet, so this syntax is just ignored here. Everything else works. Okay. Impl sub-value. Sub-row. Because I need unite value here. Okay, now over here I'm substituting the var. In order to substitute the variable, I need to say that unite shape is inference impl, unite value is shape, right? That's what I want. Substitute the type, unite shape is inference implementation, unite type shape. Substitute the row, substitute the type shape. So this over here is going to be unite value. Is it the type shape? Unite value is going to be unite inference simple unite types. No, it's not unite types because the values are unite type variant data. Let's implement this then. This function is the unite type variable data. Unite type variant data. Okay. And unite type variant data is this function. Oh, wait. But this can like fail. I was doing it with return here, and now I cannot do that. Like, because what happens if these things don't unite? I don't have an error value for this here. But it means that I'm just going to raise fail. And we're going to have exception fail here, I guess. Exception fail. So instead of this, I'm going to try. Right, I'm going to try to do this with fail is fail. Yes, of course. Weird. But okay. But then when I'm using this over here, no. I don't even see the usage in the other file. Oh my god, OCaml. Yeah, over here. I guess I'm just going to substitute the row. Substitute the var. I think this exception should be in the other place, actually. What is the range of number in that guessing game? Have you tried reading the source code? Here's the source code. Let picked. This is the number that is being picked by the algorithm. It's generating a random integer with the minimum being 1 and maximum being 10. Right? You can try changing that. Suppose. Why are you being so rude? Who, me? I'm sorry. Was I being rude? I'm sorry if I was rude. But it's a weird question because they asked for the source code, right? So I was assuming that they were reading it. They were not just trying to play the game. That is written there. All right. So yeah, what I'm trying to say is that the exception I want it to be in the in the inference base, maybe like over here somewhere. Exception fail. Wait, but what am I supposed to do with that even? Oh my god. Exception fail is the rudest streamer I've ever seen. All right. What am I trying to do? I'm trying to like catch an exception. Because I'm going to have an exception whenever I'm using this function. Well, I mean, actually, hold on. No. How is this even possible? Unite type variant data. Oh, it can fail because it doesn't have the data. Yeah. Okay. That makes. Okay. Yeah. Let me not raise this exception at all. Wait, but I won't. Maybe I just throw an error and return some something here. So the problem here is when I'm trying to there is the type inference, we see the variant. So the some of the variant types, they have the associated data, and some of them they don't. So if I'm trying to unify the two things, one of which has the data and one of them don't, then it's a failure of the unification, right? But we're trying to do error resilience here, so we actually are supposed to not panic, but give it some result. So let's, I don't know, let's unify it to some type. Then let's unify it with some type and return some type. But I will say error. Inference error error. At span expected data and no data mismatch invariant. Let's just say this. Oof, I just got a giant splinter embedded dip. Wood floors, by the way. Oof. Okay, so now I'm not throwing an exception, which means that I don't need to catch it, and it's actually easier, maybe. Variant. What am I doing? Sub row. So yeah, now when I'm substituting the row, I need to tell it how to unite the values. In this case, I'm substituting the row shape. So now the substituting the row shape also should say know how to unite values, which is a inference unite. Okay, so I just say over here unite value, and then I just pass it there. And now when I'm calling the sub row shape over here, this is sub row, and I have the unite value here, and I can pass it here. Okay, nice. OCaml has been solved. Now, does it make my language work? Wait, I didn't panic. Everything works. What did I try to do here? Hold on. The hello KS. What am I trying to run right now? Just this, which is not even printing anything. Hold on a second. This. Okay, let me though do restart my language server and see what this is inferred into. And this is inferred into an int32, which is the correct thing now. Okay, so this has been fixed in this example specifically. So let's try go back to the lists, right? So what's the type of this? An integer. Nice. Let's go back to the list example then, right? So what we're trying to do is we're trying to do the list. So we do list create. This type is a list of integers. Nice. This is correct. Now I'm trying to add this and this type checks, it seems. Okay, what if I try to add a couple things and then I try to print list like that? Okay, and then I try to run example list. Did I fix actually the language? I think I fixed the language. AI is telling that your language is a Mojo program. Did you know why? Do you know why? I'm blocked from chat too. High five. What? From Tsoding? Once I gave him a tip. Wait. Is the rudest streamer I've ever seen. Once I gave him a tip about file format, he freaked out because of my Russian language. My English is too weak for such terms. He said I disrespect chat and he blocked chat. And sorting exists. Are you guys saying that sorting is rude? Alright. I don't know. I don't watch much of it. Much coding. I don't watch him at all. But I don't know. He seems to do some fun projects. Maybe it's just his way of joking or something. I don't know, you know. But anyway, I think I fixed my bug. Let's now actually try writing programs. Right? Let me just do this. Created subvar, created new var, like this over here needs to be inside of a trace, and this needs to be inside of a trace so that we don't see these logs. Right? So yeah, in this list, we just create a new list, and then we add a 1, and we add a 2, and we add a 3, and then we call the list print function, right? And also, let's try this, right? So in this case, I'm instantiating my generic explicitly, so let's try to do it implicitly here, right? So let's start by removing these annotations. And is this going to work? This is not working because stopping on error, because type check failed. I think in this case, when I'm passing the generic into a function, this is not being auto-instantiated, so I still need to do this. Okay, and then it works. Nice. But my language server is still showing the error, which is weird. If I restart language server, then it's all good, right? And yeah, and this is inferred to be an integer. So this is inferred to be an integer. Nice. And then I think everything, like I don't need to do any type annotations because I'm using the 1 and this is inferred to be an integer, right? So this is a list of integers. Okay. Nice. Okay. Okay, this was the final bug. I think we are probably going to hit the other ones. But yeah. Let's bring back the hello world. It didn't print the list. It did. It prints 1, 2, 3. That's just the implementation of the list print function currently. List print is the function that prints everything on a separate line, right? Because in order to print the value, it just calls this function for every value, technically. So it's not even a print. This is I guess this is not a print. We should call this iterate, right? Iterate, and then we iterate it with a function. Let's let's just use the renamed here. This is a function. This is let's just use t's now instead of these weird variables, right? You got the splinter out. Nice. Should it take the list as the first argument and the function as the second then, right? Probably. Yeah, something like that. So this is going to be list iterate a using the print. There we go. Yeah, printing a list should probably have a different implementation. Okay. Fix the bug. Guys, I think there is a bug in his code. All right, what's the bug? A functional bro shedded here when you swapped order of arguments to list then function. Iter inner instead of print inner. In the over here I have a print inner. Yeah, I guess. Yeah, this should technically, like, I should change the language so that like I should say something. This is just the implementation, and this is a recursive function. And in order to do anything that is recursive, I need to introduce a module right now. Maybe let's improve the syntax here a little bit. What do we want to write here? Do I just want to say let rec, like, you know, implementation to be like this function? Is that what I want to write? And then this calls this thing recursively. And then I call this function, right? Is that what I want, or do I want something else? Because, yeah, like, so the module is a thing that allows me to have multiple recursive things, including like recursive types and like whatever. Whenever I enter the lesser numbers, it's showing that the number is greater. I don't think that's the thing. Are you sure? Okay, I mean, let me try to do that again. Fine. You're not lying. Okay, let me go back to my code. Let me run it. How do you know that it's that? Oh wait, you enter the less number is shown as the number is greater. Well, because it's saying what is that the picked number is greater. Because that's how it works. It's showing not that what you said. Maybe like maybe it is. should be different, right? Oh, I guessed it first try. Easy. 5. Yeah, like it's 5 greater. Like this just means that the picked number is greater than what I typed. Not that the thing that I picked is... not that the thing that I typed is greater. I guess this could be explained better. Let's just say this something. You know, the picked number is less. Is that more? The picked number is greater, right? Because less and greater can be interpreted differently, right? Like which one is greater? The picked number is less. Now that's more obvious, right? And yeah, I don't have the string interpolation yet and string concatenation, so that I cannot say that less than like number. That's like something that I cannot do yet, but I need to implement that at some point too. In some philosophical way, every single thing a program does is a bug. Right, how do I want this? Because previously, like again, the module is too it's too verbose. So just have this as a... just have this as a shorthand syntax. I was always wondered why OCaml or ML stuff in general use parents for multi-line blocks. For multi-line blocks at times, if they can be called blocks at all. Does that confuse blocks versus tuple versus grouping versus this? I'm doing the same for myself, as you can see here. But how is a block different from anything, from grouping? How is a block different from grouping? Because everything is an expression. When you say like, you know, like, I don't know, print hello world, right? Print hello world, this is an expression. I don't differentiate between expressions and statements. So this is a statement, this is an expression that's returning a unit type, returning nothing, right? If I put this in parentheses, that's just an expression that's just an expression that is in parentheses, which is making the priorities more obvious sometimes, right? And then we have like a semicolon, and a semicolon is another expression. It's just do this and then do that. So you just use parentheses just like you use in your math expressions. Why do you need two separate syntaxes for that? Why do you need to surround the code in like curly braces and surround the math operations in round brackets? Why should there be a difference? What is the difference? There is no difference semantically. So why should there be a difference syntactically? That's my reasoning. The only reasoning in favor of curly brackets is that you are used to the curly brackets from languages like C and like Rust, because those languages actually do make a difference between an expression and a statement. So it kind of makes sense for those languages. But for me, I think I will use the curly braces for something else. I'm not using them for anything yet. First, the curly braces look nice, but what's wrong with the round brackets? Is too many round brackets remind you of Lisp or something? Like, what's the problem? I, for example, have a statement expression for expressions wrapped as statements and statement imports, statement exports, since those two technically don't have a specific value. Unless I could somehow make them do values, which would be disastrous. Well, I mean, for me, import is actually doing a value. I can show you how my imports work, how my import system is working. So for me, everything is an expression literally, including the entire files. So the entire file is an expression. including standard library. Standard library is just an expression. I don't have the module system. The module is just a structure with fields. That's all that it is. Like in Zig, kind of. So here's the simplest example. We have a file containing 0, right? And I can import this file. I can import this file over here. So 0 is import 0. 0 is import 0. Import is an expression which evaluates to the value which is inside of this file. That's all. Similarly to how JavaScript, I guess, does imports. What exactly be the value of value math is import sin from math? Well, import sin from math is a different one, I guess. Yeah. I don't have an import from right now. So import from would be import from would indeed be a statement, but a statement is literally just an expression which returns nothing, which is returning the unit type. So it still is nothing different. It still is an expression. It's just returning nothing. Like this over here, this use, right? This over here is still an expression, but this is an expression that's returning unit, because it has the side effect of importing the things into the scope, right? So how exactly is value equal to export stuff helping? Yeah, I can see like, so the point is that if you put this on accident, because this doesn't make sense to us, like, because I can do this, right? I can say like, let x be equal to use prelude, right? Because this is an expression, I can do that. And this doesn't make sense. And you want this to be like a compiler error, because this obviously doesn't make sense to assign the result of this to the value x. But I don't know if it's like, why would it be a problem in practice? Has it ever led to a bug? To me, not yet. Not yet. If it ever leads to a bug, then maybe. There is another thing though, which I did see as a bug. So right now, these statements are just expressions that return a unit. And the bug that I did write sometime in Rust is when I was generating code using derived macros, is that so like you can forget to return something from a function, and then it means that your function returns unit. But I wanted to return a tuple, and for like that specific thing, it was supposed to be like an empty tuple. So an empty tuple and a unit type is the same thing, and I'm not sure if that's a good idea. I think there should be like the distinction between the like basically the nothing, which is the result of a statement, I guess, or a function that returns nothing, and the empty tuple. Those are different things, but there are also upsides to having them be the same thing, I guess. This also might be an interpreter versus compiler problem. Yeah, maybe. No. Wait, what is this right now? Apply must be expression. Oh, yeah. So we're back to this. Is this the syntax that I want, though? So this would be the syntax to define a single recursive thing, right? I don't want it to be like in OCaml where I do and something else. L is another like recursive thing. Because if I want to define two recursive things at the same time, then I would actually use a module, I think. But also, a module is kind of a little bit annoying, because like, so what was written here before, right? A module is a little bit annoying because because now we need to say like module name dot the actual function name, right? And this seems like redundant. In Rock, recursive functions are marked fixed point. What does that mean? Oh, you mean like fixed point is the keyword for defining recursive functions? Yeah, I don't think I want it to be called fixed point. So, but there is a reason why this is a module. Like, there is an advantages for that, because we want this language to be low level, right? And we want this recursive stuff to work without garbage collection. So, the way it's supposed to work is that this entire thing is a struct, with this being a field, and all of the fields, if there was multiple functions here, would be dropped at the same time, and this is like the arena in which we allocate these recursive things. Which is why this object should like be is nameable, especially when there's like multiple things inside. But I don't like the fact that like there is the module on its own line. I think we can just do at least, you know, like at least I have had this recursive expression previously, so we have a recursive. Go, but I don't know, it's also weird a little bit. Or maybe I at least should do like module on this line. That's another possibility. Also, I don't really like calling it module in this case. So like a rec keyword here makes more sense. But yeah, for a single thing, I think let rec actually makes sense. I don't know. Maybe I can do it as a syntax sugar. I don't know if I actually can. Syntax default rules. Let's do that real quick. Let. Okay, fine. Let's just do let rec. Let rec. Let rec. So I'm going to do let rec pattern. Then the equal must be part of this syntax. Value. So this is, yeah, like, this is like that. Okay. And then maybe this can be just syntax sugar. Maybe this can be just syntax sugar. Let's see. So I have syntax. So we can implement syntax. Let rec pattern be value as something. As what? This guy's going to say let mod be module where let pattern be value, I think. And then we just say use module dot pattern. So pattern must be like a single thing in this case. Right? Bum 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 bum. Binding mod doesn't have fields. And find implementation in scope. Implementation not found. That makes sense. Why does it say binding more doesn't have fields? Could it not figure out the type here? Oh, because it's a binding, because it's not a constant. Okay. Maybe I can say something like let pattern be mod pattern. Wait, but this is the same thing. Binding more doesn't have fields. Yeah, because this must be a constant in order to use it, right? That's the thing. Yeah, I cannot use the runtime value, only a compile time value. So I need to do let pattern be pattern. And that maybe it should work. Okay, and then we have this print inner. Okay, I mean this is a little bit nicer, right? And I can, yeah, print inner 2, and this is not print. Oh wait, I rename this, and it doesn't rename this one. Why not? What if I do rename over here? Then it renames that, and that it renames it to this thing twice. What? I have a bug, it seems, in my language server or somewhere. Go into definition though works from all of these. Finding all references. Yeah, finding all references doesn't work, which is actually weird. It only like in this place. Yeah. Okay. Anyway, I'm just going to call this simple or whatever. Let track. I'm not sure if I will keep it. I should implement something. I should try writing something. I guess I'm not doing place expressions today, but maybe like tomorrow. If I stream tomorrow, what should I do? Like if I do tomorrow place expressions, and then I don't think I stream on Sunday, and then Advent of Code is Monday, right? I mean, I can just end the stream, or I can try doing something simple. Just like writing a little bit of code in my own language would be nice. Implementing the lists further. I think I want to implement not a list though. I think I want to implement like or maybe I like want to implement the list in a different way. You know, this is the inner details which are going to be like private. I don't have private public stuff yet either, by the way. Let's just say that my list is going to be represented. I'm just trying to see if I want to do this structure in the other place, but I want to do like a trip, which will allow to have all of these operations to be like, I mean, so right now actually adding to the tail, this operation is linear in the current definition of the list, because this adds to the end of the list currently. This is linear. And this is bad. Indexing operation on the current data structure would also be linear, which is bad. So in order to have a little bit of performance, I want to have a better thing. And to implement the lists using trips for now. And maybe I will extract it to a separate thing later. So like, yeah, it's either an empty list or it's a cons, but I'm going to have basically a binary tree here with the left being list T and right being list T, and the value in the middle being T. And also we want another value, which is the priority, which is going to be an integer. So I'm going to do a trip with it being the heap over the priorities, and that is going to achieve, with randomized priorities, it's going to achieve the logarithmic complexity on these things. So in order to add, oh, my error message is horrible here. Okay, in order to add to a list a value, yeah, we need to like basically have two operations. Oh, and also I want to like have some data which we calculate for the things. So we want to have the count. The count in the entire subtree is what I want. So we need two operations. Let me do this over here. Node. I'm just going to call it node because I maybe will. Move it to its own thing. So I want to have a function merge. Well, I mean, first we want to like construct a singleton, right? A singleton is a function that takes value of type T and returns the node of T. That's going to be just cons, where left is empty and right is empty. Value is the value, and count is 1, and priority is RNG gen int 32, I guess. Minimum is 1, 0, maximum is 100. I mean, for now it doesn't really matter. I need to just do a random integer without the things, I guess. This shows a bug. It's things that left is a different type. What is this 355? This is the same one. This one is different, which is weird. I still have some issues, I think. Maybe. But let's see. So we have singleton, then we have merge T, and we will merge the left node, and we merge it with the right node. We get a new node as a result, and basically we say that, yeah, need to match left and right with If it's both empty, then we return empty. If it's empty and other, then I return other. If it is other and empty, I return other. But if they are both not empty, so this is cons A and cons B, then what I want to return is return empty for now. Oh, I need to not use the commas here. Commas are wrong. This is not a camel. It seems like this has a different priority. So I need to make this in parentheses. Okay, yeah, this seems like it's compiling. All right, let's see next. So if we have, if we were trying to merge actually two non-empty things, then I'm going to compare the priorities. If A priority is more than B priority, then I do one thing, and otherwise I do another thing. What I'm doing here? I'm trying to make A the root of the new thing. So I'm doing cons, and A is the left one. Let me call this left, and this right. Still, because they are ordered. Left. So we have left. So over here, yeah, we have left is left dot left. We have right. Well, value is left value. Priority is left priority. Now right is going to be merge left, right, and right. Merge. This is a recursive thing. Wait, I have a to-do compiler source. Why is there a to-do somewhere? Oh, I need a comma here. Okay, just type check fails. Okay. And then we have a count. And what's count? And counting is something. Yeah, let's do cons here. Let's do update. Left with these things. Where update is a function that takes a function that takes root and left and right and returns cons. Value is root value. Priority is root priority. Left, right, and then the count is going to be 1 plus count of left plus count of right. Then we have the function count. node. This returns an integer. So it's going to match node with empty, then it returns 0. And if it is cons, v, then I return v dot count. You're writing the commas, which makes no sense. Okay. This is the thing that returns a node t. Type check fails. All right. Value checked. Cons does not equal to unit. Wait, something is expecting to be a unit? Yeah, just finished writing my review portfolio on Steam. What do you think? Anti-environmental deforestation initiatives, colonial imperialism, the industrial expansionism, environmental hazards management, interstellar monopolistic regime enforcement, in illegal resource extraction operations, automated system defense protocol, advanced logistic coordination, etc. What else could you ask more from a game? 10 out of 10. Yeah, maybe. Nice. I don't know. I'm sorry. My brain doesn't really work right now. I'm going to try using my language a little bit, see if it's actually usable here, and I'm going to end the stream soon. My question for you, what I struggle with, how do you define STD and ensure you don't hard code STD items? Yeah, I don't hard code anything, but I have the special what's your process for preluding STD and make the language recognize STD? Oh, you mean like, so there's, I think, two things, right? First, how do you connect STD with like the built-in things? Right now I'm having like the interpreter, but if it's the compiler, how do like I connect the things together? So I have this expression, which is called a native expression. So over here we have the stdio print, for example, right? It's defined like this. So stdio print is a function which, in case of us being running into the interpreter, it's using the native print function. So a native is the thing which is dependent on the target. Right now it's the interpreter only, right? So this thing is the thing that is defined inside the interpreter, right? So a native can be only like interpreted, and then the interpreter knows what the print is actually, right? Something like that. And similarly, I'm defining like my types, right? So I'm not hard coding my types. My types are defined in the interpreter using the same like native expression. And then the process of actually saying that the STD is like available to all the programs is I am literally just evaluating the standard library using the interpreter, which does not have anything in it. So I have evaluated that as a value, and then I assign that to a variable called std, and then that's the interpreter that is used for actual programs, right? Let me see here. Std. Yeah, over here, see? We have the interpreter without the std, so I'm creating that, and then, so I bootstrap the stuff, right? And then I'm importing the standard library, which, like, I mean, I guess it does have to be the interpreter. If you don't know doing the interpreter, you're importing the standard library. and then you are assigning that to the symbol std, and then you use the like compiler, or in my case interpreter, because compiler is interpreter for me, with standard library, which is like that, you know. Because in your languages, string, int, etc. are all just UDTs. ADTs, you mean? Algebraic data types? So how in the ever-evolving hell will I make the compiler recognize them without some magic? Oh, user-defined types? But how, if they are user-defined, why do you even need the compiler to recognize them? Should they even be? Like, if they are user-defined, then they're user-defined, right? One thing for sure is I could have written that review for Satisfactory, not even have the things mentioned applying there. Oh, you could not have? Yeah. How does the compiler know what a string is? Does it need to know what a string is? Why does the compiler need to know what a string is? Like, string can be defined in the standard library, right? Like in C. C doesn't know what a string is, right? It's built using the pointer type and a character type, right? A char star. I mean, it depends on the language, I guess. Yeah, string is just an array of runes, so yeah. Why does it need to be recognized by the compiler at all? It should behave as if it is fully user-defined, right? If you can. Do-do-do-do-do-do-do. Cons left, cons right. Interesting. How would the compiler know? Oh, double quote literal. Yeah, that's the string here. Take this. Yeah, I guess that's the only connection. Yeah, sure. Well, there are different ways. I mean, do you have compile time evaluation or not? And bin is binary float. I don't know why would you call your floats bins? That's weird, but okay. One of the things that, like, I mean, you still need some built-in type, right? Yeah, I don't know. Yeah, you need some magic. So in my case, my magic is really simple. I just have the native thing, right? So, but you can make it, like, technically this native things is just like, this is just a value. So you can have the types to be like defined inside, not the standard library, but in the thing, you know. I don't know. Like, there are different ways, I guess, to do that. You can have a duplicated, one of the options is to have the duplicated definition, one in the actual standard library and one in the compiler itself, right? And then just, I guess, assert that they are equal, for example. Because having the definition in the standard library means that you can, like, use the language server to go to the definitions and stuff, which is nice. Which is something that I would not be able to do if I keep using it for more types myself. Maybe. Binary decimal separation, so I need to make an extern constant for an extern struct. Yeah, but going to just bin is weird. You can say binary float, for example. That would be better. Just bin, because there's a lot of things that can be binary, right? You know? Like bin 32, I don't know. Not only floats can be binary, you know? Okay, call them bin IEEE. then the standard. So it's IEEE.bin, then maybe if you want to follow that standard. I don't know. I gotta call my new language bin so that when people tell me that it's trash, they won't be wrong. If integer is int, then binary decimal is bin dec. Yes, but why is binary a float? That makes no sense. The reason why IEEE uses names binary or decimal is because IEEE is specifically about floats. It's because, like, in the context of the IEEE, it makes sense to call them binary or decimals. But outside of the context of that specification, a lot of the other things can be binary. Like integers can be binary, for example. Yeah, I would call them like binary float or decimal float, for example. Maybe that's better, in my opinion. Or like I said, you can have, like, instead of I mean, I don't see what's wrong with calling them floats. Why don't you like calling them floats? Also, there are some languages that are calling the normal float and the other one the decimal. Although, I don't know. I mean, decimal for floats makes more sense than using binary because, yeah, I don't know. I don't know. I don't know. I don't know. I will have to think about this myself at some point, I guess. Float is ambiguous. Yeah, sure. Float is ambiguous. Maybe. But when you think about decimals, I'm actually thinking about big decimals for some reason. So, I don't know. Is there any other language that actually has the decimals? Wait, are you saying that decimals are part of the specification so they can, like, can my, like, so my CPU knows about the decimal floating point numbers? By the way, they call them single, so shouldn't you be calling this one single? Oh, wait, 32-bit single. Yeah, they call it single and double. And quadruple and octuple. And a half. I guess, and this is the alternative name. Swift has small decimal. In this language called Viper, decimals are just int 168 with 10 decimal places. Yeah. Like, yeah, but yeah. Technical standard. But is this, like, supported by the CPUs natively, the decimals? Like, why do you even want to support that? If it's... Because if it's not, like, something that is implemented directly, then I would not even include it in the standard library. Alright, let me keep writing this. I have some errors here, which is actually weird. It says empty or cons or cons. Empty or cons? Empty or cons? Interesting. Oh, you fixed it. Yeah, I fixed it. I'm trying to use the language right now. I'm trying to write a trip. And then I will use this as an implementation for my lists. What? A trip. It's like a tree and it is a binary tree and a heap at the same time. A trip. Yeah, and I'm doing this like randomized binary search tree basically, right? Where the priorities that the values that we use for the heap part are randomized, which because it's randomized, it can be proven that the height is proportional to the logarithm of the number of keys, which is how you get the logarithmic complexity of the algorithms, and it's kind of easy to write this data structure. But my type errors right now are really bad, by the way. If you are thinking about using my language, for now, the types are bad. When I have the named types, it would be a lot better, I guess. Also, maybe the reason it's bad because I'm using the anonymous types right now, and I should maybe anonymous types is not a very good for that reason. I will never forget the problem you had with subst and infer. It took me a whole day to shut the compiler up. I don't know what is subst and infer for you, but maybe you were fixing the same thing that I was fixing today. I was fixing substitution and inference, right? Substitution inference, that's what I was fixing today. And yesterday too. It was painful, I agree. I don't know if you're fixing the same bug or not. If left priority is more than right priority, then we do this. Oh, maybe like if I do a semicolon here. Okay, that helps a little bit. This doesn't have fields. Why not? Cons left and cons right. What's the type of this? Is it because I'm using like the same value? I'm having okay, hold on. Let me call this left 2. What is the type then? The type is still incorrect. Because the type should be this tuple, right? Okay. You think the cast rewrite should start with good error messages? I mean, I can improve them I can improve them soon. Like I said, when I have the named types, it will be already a lot better. Okay, anyway, let's do this update. Right and left is merge t left and right dot left, and right is right. Needs some left to get left dot priority, but it's all like I already did the pattern matching here, right? So this is pattern matching on left and right at the same time, and we know that left is already a cons, right? Which means that the data associated is this thing, which should have the dot priority field over here. This is the definition of the type, right? And this is what I return, actually, like so. Let me return empty here. And like comment all of this out. So this still says that type check failed for this function update. One thing I want to try is OpenGL bindings in my language. Yeah, that will be my goal. I will be doing that too. But I will be starting not with GLFW and not with OpenGL specifically, but with WebGL, and I will be targeting the web first before going native. But native is also planned, but for the future. Targeting JavaScript is just easier, in my opinion. And the guy that's obsessed with C99 is also really wants to do that in your language because guy's obsessed with old OpenGL on old devices. Yeah, I'm also using really old OpenGL. But not that old, I guess. I'm using like 3.3, not the stuff that's earlier. OpenGL 3.3, OpenGL ES2, and WebGL 1. That's what I'm going to be targeting, probably, unless I choose, like, maybe, like, there's, like, the Web GPU that's the new standard, but I don't think I'm going to go for that. I'm going for the OpenGL, I'm pretty sure, still, because that's already that I know. So what's the problem here? This function is the function that's returning node t. What if I don't specify that? Well, then it doesn't know that root has... Oh, over here. Yes, root is node t. Okay. Yeah, I need this to be like, you know, node data t. That's right. Const node data is t type that. There we go. I see my language server is lagging. How much do you think of the RAM am I using yet? Am I using 1 billion, 25 gigabytes of RAM? My cast language server is using 50% of my memory currently. What the fuck? Yeah, I think I have a leak somewhere. I'm pretty sure I have a leak. What do you use to make the LSP? I'm using the linol library. Linol over here. If you're using OCaml, maybe you can look into that too. There's an example here for the simple LSP. I'm using the one with EIO. Okay, I'm just going to reload the window here. I think also, like, the cast binary is still there. Do I need to kill it manually? Pkill cast. Okay, now we're back to 8 gigs. Okay, nice. Eventually I will be bootstrapping most of the language, so I need to make an LSP binding for my language too. Yeah, that's what I'm doing. Why I'm doing the LSP. I want to get into the self-hosting relatively soon because I don't really like OCaml. Hello, 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 hello. Oh, it's lagging. Oh, it's lagging. Also, is it spawning 2 language servers? Why is there 2 cast binaries? Doesn't even work anymore. Maybe because I have the compiler errors. I don't know. Oh, it actually, oh, I have the infinite recursion again, or like whatever. Yeah, see, my stuff is hang here. Okay, now I need to write my standard library without the autocompletion, without the LSP, it seems. Alternatively, I could give on LSP and a camel and do it in Rust. For Wasm, I'll definitely need Rust. You don't need Rust for Wasm. You can generate Wasm yourself. I am compiling my OCaml code base to JavaScript. Why do you even need Wasm? You can just transpile OCaml to JavaScript. That's how I'm powering my playground. By using JS of OCaml. Yeah, I literally have the LSP working in the browser already. I just don't have it working locally now because I broke my standard library or something. Let's see. Empty or const doesn't have fields. So root, yeah. So this is not node. This is node data, right? And left is node, and right is node. There we go. And then we have inference failed at substitution. Okay. Now I don't even see where it happened. Empty or const had tail. And then this. Oh, because list is a node now. Yeah, I guess I need to like comment this part out too for now. And then examples, I go to hello world instead. It's still this file that is like doing infinite recursion, it seems. So I still have bugs. Okay. Let me try to write this further though, anyway. What are you going to say? It says this type empty or const doesn't have fields, right? Which makes no sense here. Can I say that over here this right is of type node data t? Same goes for the left here. It still says the same. Maybe in my wait. Does my pattern match? Maybe my pattern matching is weird. I guess. Like it thinks that this is the other variable or what? Let's call this right data. Let's call this left data. Left data. Left data. Right. Yeah. Oh, wait. That makes sense. Why? Yeah, because. Okay. Yeah. I actually need these to be of. Right data. Left data. Field priority is not there. Okay. but it is literally there. Okay, node data, field priority is not there. But it is there. Specifically about priority, they didn't complain about the value, for example. And this is the same word, there is no typos. And then I have some inference type checking issue. Okay, I think I maybe need to fix a little more stuff. But I need to figure out what. I need to like try to minimize this example. Right? Let's go back to the previous definition of lists. I'm going to copy this to a separate file. Let me call it, you know, the trip. That's the trip that I want to write. Yeah. So now I should be able to reload my window. That will let me have my language server back, right? Because this works, okay. So in theory, let's just see again. So if I do const trip is include trip, this is going to try doing that, and now we are hanging. Yeah, so I don't want to do that. Okay. Now we'll try to figure that out and maybe minimize this example. Then, but I think unless there is a bug here, this merge function is ready. So yeah, whip trip. Fucked up with time on my domain controller, and now I can't connect to it. What's the domain controller? A gamepad? That's a controller? What's a domain controller? It's a server that manages and authenticates the user and computer access within a network. A network server that is responsible for allowing host access to domain resources. I don't know how I never saw this before. I don't know. I didn't know what it is. Boom 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 boom. Ding ding.
Nee. Oh, nee.
Alright. You guys next time. Thank you for watching. Here's some Lisp
Friday.
for you.
I thought this was appropriate, you know.
On L:2 channel.
World, you know, they're talking about Black Friday today. They're talking about
they like Lisps here when they're not talking about Black Fridays, I guess.
And things like this.
Right,
they're
bye.
Talking about, I don't know, what do you call this? No Black Friday. Oh, I guess we did do this in the past.